उगते सूरज से नोक झोंक हर दिन करते हैं, अपने पक्के इरादों से मुश्किलों को हराते हैं। राहें कितनी भी कठिन क्यों ना हो, ये तो इनको और भी मजबूत बनाते हैं। ये बने हैं कुछ कर दिखाने के लिए, ये बने हैं आसमां के पार जाने के लिए। इरादे और सपने तो इनके ही हैं, हम तो बस इन्हें पंख देते हैं। Nothing was easy, but we made it easy. Made easy, celebrating 20 years of excellence.
Good evening, friends. Welcome to the live solutions for the Electronics and Communication Engineering, the GATE 2021, February 7th. Okay. See, these questions we have collected from students and it is based on memory. हमने ये सभी questions जो है students से लिए हैं based on their memory. So there may be some incomplete questions or some wrong data. Okay. Please excuse us for that. But जैसे जैसे we get the correct questions, we can provide you the improvised better solutions. Okay. So let's get into our solutions. My name is Shastri. Most of you might be knowing me. I'm a faculty of digital electronics. Okay. Let's get into the questions. I have collected 3 questions. They have told they have around 5 questions. Some student was telling we could collect only 3 till now. Subsequently, we'll update with the next set of questions. A simple question based on the DAC. Okay. हमने क्लास में पढ़ा होगा DAC सर्किट. DAC सर्किट का उसने क्या किया, सिंपल क्वेश्चन पढ़ लीजिए, फुल स्केल आउटपुट दिया है, ही गेव द फुल स्केल वैल्यू, यानी DAC सर्किट का क्या किया, फॉर द DAC सर्किट ही गेव द फुल स्केल वैल्यू 7.68 वोल्ट्स. ओके, ही इज आस्किंग द आउटपुट वोल्टेज एंड इज आल्सो टेलिंग 8 बिट DAC. ठीक है, जब 8 बिट DAC बोल ही रहा है, whenever is telling 8 bit DAC, you can easily find the resolution. ओके, रेजोल्यूशन निकाल सकते हैं. रेजोल्यूशन K is equal to, the resolution K is nothing but, you know the formula, full scale by 2 power n minus 1. ये तो हमने क्लास में कई बार किया है. ठीक है, so you can easily calculate the resolution. और उसे क्या पूछ रहा है, he is asking the output voltage for this binary input. DAC का, ठीक है, आउटपुट वोल्टेज पूछ रहा है फॉर दिस बाइनरी इनपुट. इसका डेसिमल इक्विवेलेंट निकाल लीजिए. यू फाइंड आउट द डेसिमल इक्विवेलेंट फॉर दिस. इसका डेसिमल इक्विवेलेंट निकालेंगे फॉर दिस नंबर, यू आर गोइंग टू गेट 150. डेसिमल इक्विवेलेंट निकाल लीजिए, वो तो आप कर सकते हैं. सो व्हाट इज, हाउ डू यू फाइंड द आउटपुट प्लीज, VDAC. okay, DAC output is equal to, output of the DAC is equal to resolution K into decimal equivalent of the input. Simple formula, please understood. Simple formula, ये formula ये भी हम जानते हैं, we have done so many questions of this model. ठीक है, so if you just make a simple substitution, understood, simple substitution, ये होगा 7.68 upon 2 power 8 minus 1, which is 255. तो ये आप यहाँ ये आ गया अपना K value. So VDAC will be is equal to, so simply 7.68 upon 2 power 8 minus 1, यानी 256 minus 1, 255 into 150. इसको आप कैलसी बेस सॉल्व कर लीजिए, अंडरस्टूड. के आंसर विल बी अप्रॉक्सिमेटली 4.51, ऐसा कुछ आएगा. ओके, सो द आंसर फॉर दिस क्वेश्चन इज 4.5. इट्स वेरी सिंपल क्वेश्चन. ये हमने सो मेनी क्वेश्चंस वी हैव डन इन द क्लास. ओके, इसमें कुछ भी कॉम्प्लेक्सिटी नहीं है. सिंपल क्वेश्चन बेस्ड ऑन सिंपल DAC फॉर्मूला, प्लीज अंडरस्टूड, सिंपल DAC फॉर्मूला. ओके, थैंक यू. लेट्स गो टू द नेक्स्ट क्वेश्चन. Okay, this question is basically based on a critical timing analysis. हमने ये क्वेश्चन भी क्लास में कराया है. Because similar questions have come in GATE 2017 and 2018 में ये मॉडल क्वेश्चंस आए हैं. This question is based on the critical timing analysis. Okay, it's basically based on the critical timing analysis. ठीक है, तो वो क्या पूछ रहा है. ठीक है, ये मॉडल क्वेश्चंस हमने स्पेसिफिकली हमने लिया है क्लास में. अगर आपको याद होगा, स्टेबिलिटी के बारे में पढ़ाया, क्रिटिकल टाइमिंग एनालिसिस के बारे में पढ़ाया. दिस क्वेश्चन केम फ्रॉम द टॉपिक ऑफ क्रिटिकल टाइमिंग एनालिसिस. उसने क्या किया, 2 मल्टीप्लेक्सर दिया. ठीक है, ही इज आस्किंग द टोटल प्रोपगेशन डिले. उसने क्या किया, इनपुट अप्लाई कर दिया. क्या इसी इनपुट अप्लाई कर दिया. व्हेन यू अप्लाई इनपुट, क्या होगा, पूरा सिस्टम काम करना शुरू करेगा. ही इज आस्किंग द मैक्सिमम प्रोपगेशन डिले. सर्किट का क्या पूछ रहा है, ही इज आस्किंग अस द मैक्सिमम प्रोपगेशन डिले. बट ये क्योंकि मल्टीप्लेक्सर होते हैं, दे आर पाथ डिपेंडेंट. एक चीज याद रखिए, हमने क्लास में भी कराया है, व्हेन देयर इज अ मक्स, ओके, इट्स ऑलवेज पाथ डिपेंडेंट. प्लीज अंडरस्टूड, पाथ डिपेंडेंट होता है. ओके, इट्स ऑलवेज पाथ डिपेंडेंट, ठीक है। सिंपल आपको क्या करना है इसको सॉल्व करने के लिए, t0 दीजिए, बहुत सिंपल है, जस्ट अप्लाई t इक्वल टू 0, ठीक है। जब t0 देते हैं तो ना एंड गेट का कितना डिले दिया है, एंड गेट का 2 नैनोसेकंड दिया है, इसका 4 नैनोसेकंड्स दिया है, या 2 है, मक्स का 1 नैनोसेकंड, 1 नैनोसेकंड या 2 नैनोसेकंड्स। अब सेम इनपुट इज अप्लाइड, ठीक है। सो अब t0 दीजिए, लेट्स कैलकुलेट द टोटल डिले, t0 दीजिए, जैसे 0 देंगे यहाँ पे भी 0 होगा, यहाँ पे भी 0 होगा, ठीक है। तो क्या होगा, यहाँ पे I0 सेलेक्ट होगा, यहाँ पे भी I0 सेलेक्ट होगा। नाउ लेट अस सी द टोटल डिले, सर्किट में पूरा टोटल डिले देखते हैं, अंडरस्टूड, टोटल डिले देखते हैं। तो देखिए यहाँ पे देखिए, जैसे मैं इनपुट अप्लाई करता हूँ, ये 4 है और ये 1 है, ठीक है। सो इन दोनों का अगर आप देखेंगे, अंडरस्टूड, 4 + 1 5 नैनोसेकंड्स, ठीक है। इन दोनों का देखेंगे 4 + 5, 4 + 1 is 5। यहाँ पे देखिए एक और पॉइंट, दिस फ्लिप फ्लॉप का 0 जो है सीधा इनपुट से आ रहा है, कि सॉरी फ्लिप फ्लॉप नहीं, सॉरी इस मक्स का जो इनपुट जो है सीधा इनपुट से आ रहा है। दैट मीन्स दिस मक्स इज डायरेक्टली वर्किंग ऑन द इनपुट। जब आप 0 देते हैं, इस मक्स का इनपुट सीधा इनपुट से काम कर रहा है, अंडर सीधा इनपुट से काम कर रहा है। सो व्हाट इज गोइंग टू हैपन इज, ये 4 + 1 5 लग रहा है, ये दोनों मिला के 4 + 1 5, इसी समय में ये भी काम कर चुका है, क्योंकि इसका इनपुट जो है सीधा इसका 0 जो है इनपुट से आ रहा है, इस पर डिपेंड नहीं कर रहा है। सो इस पाथ का देखेंगे, क्रिटिकल पाथ इफ यू सी, यू आर गोइंग टू गेट 5 नैनोसेकंड्स, मैक्सिमम डिले इस केस में 5 होगा, ठीक है। उसी प्रकार देखेंगे t1 दीजिए, ओके, जस्ट अप्लाई t इक्वल टू 1, ठीक है। सो दिस इज 2 नैनोसेकंड्स, 4 नैनोसेकंड्स, 2 नैनोसेकंड्स प्लीज, अंडरस्टूड। अब देखिए t इक्वल टू 1 दीजिए, I1 सेलेक्ट होगा। नाउ लेट अस सी द टोटल डिले, तो ये 1 नैनोसेकंड है, ये 1 है। नाउ लेट्स कैलकुलेट प्लीज। सो इफ यू जस्ट ऑब्जर्व हियर, दिस इज 2, सो ये 2 + 1 3 होगा। नेक्स्ट दिस 2 + 1 3, 3 + 2 इज 5, 5 + 1 इज 6। सो इस पाथ में काम करेगा, तो इसका डिले है इस पाथ में 6 नैनोसेकंड्स है। तो क्या हुआ, t0 पे 5 नैनोसेकंड्स आया, ठीक है, t1 पे 6 नैनोसेकंड्स आया। आंसर किसको लेना है, 6 नैनोसेकंड्स। आंसर इस क्वेश्चन का 6 नैनोसेकंड्स है, अंडरस्टूड, 6 नैनोसेकंड्स है, ठीक है। ये एक और क्वेश्चन देखिए, ये है नंबर सिस्टम्स का, he did not ask, ठीक है, वेरी सच a simple and silly question, simple calci based question, ठीक है। अब देखिए, इफ यू जस्ट ऑब्जर्व हियर, ठीक है, सिंपल नंबर सिस्टम्स बेस्ड क्वेश्चन दिया, सिंपल बेसिस। इसको क्या करेंगे, कन्वर्ट इनटू डेसिमल, बताने की जरूरत भी नहीं है, डैश 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 डैश। सो एक्स पावर डायरेक्टली कर देते हैं, देखिए इसको लिख सकते हैं x क्यूब, x स्क्वायर, x पावर 1, x पावर 0, ओके। सो क्या होगा बताइए, x क्यूब प्लस 2x स्क्वायर प्लस, ओके, 3x प्लस 5। इसको भी डेसिमल में कन्वर्ट कर लीजिए, तो क्या होगा, दिस इज y क्यूब, y स्क्वायर, y पावर 1, y पावर 0। सिंपल सब्स्टिट्यूट कीजिए, सो क्या होगा, 3y क्यूब प्लस दिस इज 3y प्लस दिस इज 3, ओके। इन दोनों को जस्ट आपको क्या करना है, इसको सॉल्व नहीं कर सकते हैं, इसको केवल ऑप्शन सब्स्टिट्यूशन से करना है। दिस कैन बी डन बाय ओनली यूजिंग ऑप्शन सब्स्टिट्यूशन। सो अलग अलग ऑप्शंस दिए गए हैं, लकीली क्या हुआ, ऑप्शन ये मैच कर देता है, ओके। सिंपली सब्स्टिट्यूट, ओके, x इक्वल टू 8, y इक्वल टू 6, ओके, x इक्वल टू 8, y इक्वल टू 6 सब्स्टिट्यूट करेंगे, पुट करेंगे इसमें, ठीक है। If you put these two, so your answer will tally, understood, answer will tally। Simple question please, based on simple calci question, just आपको substitute करना है। If you substitute, you will going to get both the values will get tallied, understood, tallied। So answer for this question is yeah, okay friends, thank you very much, okay। Now my colleague Rohit Tripathi will be there for signals and systems. Thank you, all the best।
एक मिनट में देख लेता हूँ। Good evening everyone. Myself Rohit Kumar Tripathi and I am signal and system faculty in MEDISI। तो मेरे पास कुछ क्वेश्चंस हैं जो गेट 2021 के हैं, जो सिग्नल एंड सिस्टम से रिलेटेड हैं। तो बेस्ड ऑन मेमोरी बेस्ड डाटा मैं इसके आंसर्स लिखूंगा। मे भी हो सकता है कुछ डाटा मिसिंग हो या फिर रॉन्ग हो, तो उसके अकॉर्डिंग इसमें चेंजेस, आंसर में चेंजेस आने के चांसेस हैं। तो क्वेश्चन 1 इस फॉर्म में कुछ इन्फॉर्मेशन सिग्नल एक्स टी से रिलेटेड गिवन है. सो फर्स्ट इन्फॉर्मेशन इज सिग्नल एक्स टी इज अ रियल इवन फंक्शन. सेकेंड इन्फॉर्मेशन इज एवरेज वैल्यू of signal xt is equal to 2. थर्ड इन्फो गिवन है for signal x of t एक्सपोनेंशियल फोरियर सीरीज कोएफिशिएंट इज ak और ak के सैम्पल्स गिवन है. ak इज इक्वल टू k when k is between 0 to 3 and it is 0 for k greater than 3. मतलब LHS के सैम्पल्स नहीं गिवन हैं, बस केवल RHS के सैम्पल्स गिवन है. और फोर्थ इन्फॉर्मेशन गिवन है फंडामेंटल टाइम पीरियड ऑफ सिग्नल इज 6. सो कैलकुलेट पावर ऑफ सिग्नल x ऑफ t. ठीक है, तो ये जो इन्फॉर्मेशन गिवन है इसमें पहला काम हम लोग करेंगे फॉर रियल इवन सिग्नल एक्सपोनेंशियल कोएफिशिएंट विल बी आल्सो रियल इवन. तो मैंने फोरियर सीरीज का एक पेयर यूज़ किया है. अगर सिग्नल रियल इवन होता है तो उसका एक्सपोनेंशियल कोएफिशिएंट भी रियल इवन होगा, मतलब एक ही कैसा मिलेगा, रियल इवन. अच्छा, अब एक का नेचर कैसा है, रियल एज वेल एज इवन. इसे आप इस फॉर्म में भी लिख सकते हैं, सिंस ए के इज रियल इवन सो ए ऑफ माइनस के विल बी इक्वल टू ए ऑफ के. अब ए ऑफ माइनस के ए ऑफ के इक्वल है. अब आप इसको यूज़ करेंगे तो के बिटवीन 1 to 3 अगर के इक्वल है, ए के 1 to 3 वाले रेंज में के इक्वल है, तो ए माइनस के 1 to 3 वाले रेंज में ये भी किसके इक्वल होगा, के इक्वल आएगा. इसका मतलब a माइनस 1 a1 के इक्वल होगा. और a1 किसके इक्वल है, k इस वाले रेंज में आ रहा है तो k को आप 1 पुट करो तो कितना आया, 1. इसी तरह a माइनस 2 किसके इक्वल आएगा, a2 के इक्वल आएगा. k इक्वल टू 2 पर a का वैल्यू लिखना है, किसके इक्वल है, k के इक्वल. अभी k कितना है, 2, तो इसकी वैल्यू कितनी होगी, 2. इसी तरह a माइनस 3 लिखना है तो a माइनस 3 किसके इक्वल होगा, a3 के इक्वल होगा. अच्छा, a के इक्वल टू 3 पर लिखना है, k इक्वल टू 3 पर आप देखिए यहाँ पर k के इक्वल है और k की वैल्यू अगर 3 होगी तो a के भी कितना लिखूँगा, 3 लिखूँगा. मतलब a3 3 के इक्वल है और a के a1 है तो a माइनस 3 भी किसके इक्वल होगा, 3 के इक्वल होगा. तो फिलहाल हमें 6 सैम्पल्स मिल गए हैं a के. अब इसके बाद इन्फॉर्मेशन 2 आप यूज़ कर लो. तो ये जो इन्फॉर्मेशन 2 है ये क्या रिप्रेजेंट कर रहा है, DC वैल्यू ऑफ सिग्नल xt. एक्सपोनेंशियल कोएफिशिएंट में k इक्वल टू 0 पर जो भी वैल्यू होती है वो सिग्नल का DC वैल्यू होता है. इसका मतलब a0 की वैल्यू कितनी है, 2. तो सेकेंड इन्फॉर्मेशन से हम लोगों ने a0 का वैल्यू कैलकुलेट कर लिया, a0 की वैल्यू कितनी है, 2. और इस रेंज के बाहर मतलब k इक्वल टू -3 से k इक्वल टू 3 वाले रेंज के बाहर जितने भी सैम्पल्स हैं वो एक के कितने हैं, 0. ये कैसे पता चला, थर्ड इन्फॉर्मेशन से, क्योंकि थर्ड इन्फो कह रहा है k ग्रेटर देन 3 के लिए एक के सैम्पल 0 है तो k लेस देन -3 के लिए भी एक के सैम्पल्स 0 होंगे. तो इस तरह AK में नॉन ज़ीरो सैम्पल्स मैं फटाफट लिखूं तो AK में नॉन ज़ीरो सैम्पल्स है a माइनस 1 a1 के इक्वल, फिर a माइनस 2 a2 के इक्वल, फिर a माइनस 3 a3 के इक्वल. a1 कितना है, 1, a2 कितना है, 2, a3 कितना है, 3 और a0 अभी हमने कैलकुलेट किया कितना है, 2. कैलकुलेट क्या करना है दोस्तों, पावर. तो पावर कैलकुलेशन के लिए आप किसे यूज़ करेंगे, पार्सेवल्स पावर थ्योरम को. पार्सेवल्स पावर थ्योरम आप इस फॉर्म में लिखते हैं, पावर ऑफ सिग्नल xt विल बी इक्वल टू समेशन मॉड AK स्क्वायर, रेंज ऑफ k -3 to 3. फिर लिखूँगा समेशन मॉड AK स्क्वायर. k किस रेंज में अवेलेबल है, AK अगर आप देखें तो AK यहाँ पर हम लोगों ने देखा है AK में जो सैंपल है वो -3 से 3 वाले रेंज में मिलेगा. तो k का रेंज मैं -3 से कहाँ तक पुट करूँगा, 3 तक. अब आप इसमें k के वैल्यूज़ को पुट करते जाओ तो a-3 मॉडलस स्क्वायर, ऐसे लिखते लिखते कहाँ तक लिखना होगा, a3 मॉडलस स्क्वायर तक लिखना है. ठीक है, तो k को यहाँ -3 पुट करो, a-3 मॉडलस स्क्वायर, फिर k को -2 पुट करो तो a-2 मॉडलस स्क्वायर एंड सो ऑन. कहाँ तक लिखना है, a3 मॉडलस स्क्वायर तक लिखना है. अच्छा, a-3 की वैल्यू कितनी है, 3, तो आप लिखोगे 3 स्क्वायर. फिर a-2 कितना है, 2, तो लिखो 2 स्क्वायर. फिर लिखो a-1 स्क्वायर, a-1 कितना है, 1 स्क्वायर. फिर लिखो a0 स्क्वायर, a0 कितना है, 2, तो 2 स्क्वायर, A1 स्क्वायर 1 स्क्वायर के इक्वल, A2 स्क्वायर 2 स्क्वायर, A3 स्क्वायर 3 स्क्वायर। ठीक है, अब अगर आप इन सब को ऐड करो तो रिजल्ट कितना आएगा 32। तो इस क्वेश्चन का आंसर क्या है 32। चलिए अब नेक्स्ट क्वेश्चन देखते हैं, नेक्स्ट सवाल देखते हैं क्या है। नेक्स्ट क्वेश्चन सैम्पलिंग से रिलेटेड है और कुछ इस फॉर्म में है। फॉर सिग्नल x ऑफ t, सिग्नल एक्स टी इज बैंड लिमिटेड, सिग्नल एक्स टी इज बैंड लिमिटेड सिग्नल, बैंड लिमिटेड सिग्नल। For signal xt, maximum frequency component is 10 kilohertz, is 10 kilohertz। तो xt की मैक्सिमम फ्रीक्वेंसी कितनी है 10 किलोहर्ट्ज। नेक्स्ट रिलेशनशिप है बिटवीन yt एंड x ऑफ t, yt इज इक्वल टू xt इंटू एक्स ऑफ t बाई 2 प्लस 1। ठीक है, और कैलकुलेट करना है नेक्विस्ट रेट सिग्नल y ऑफ t के लिए। तो इसे हम लोग इस तरह सॉल्व करेंगे। सबसे पहले सिग्नल एक्स ऑफ टी में मैक्सिमम फ्रीक्वेंसी कंपोनेंट कितना गिवन है 10 किलो हर्ट्ज। जब आप टाइम शिफ्टिंग परफॉर्म करेंगे तो मैक्सिमम फ्रीक्वेंसी कंपोनेंट में चेंजेस नहीं होंगे। इसका मतलब फॉर एक्स ऑफ टी प्लस 1 मैक्सिमम फ्रीक्वेंसी कंपोनेंट विल बी सेम एंड इट विल बी इक्वल टू 10 किलो हर्ट्ज। अब आपने टाइम को स्केल किया कितने से 1/2 से, तो आप लिखेंगे x ऑफ t बाई 2 प्लस 1। अब आप खुद सोचो, आपको अगर यहाँ से यहाँ तक आना है तो आपको टाइम डोमेन में क्या करना होगा, एक्सपेंड करना होगा। टाइम डोमेन में क्या करना होगा, एक्सपेंड। अगर आप टाइम डोमेन में एक्सपेंड करोगे तो फ्रीक्वेंसी डोमेन में क्या करोगे, कॉम्प्रेस, क्योंकि टाइम और फ्रीक्वेंसी एक दूसरे के अपोजिट पैरामीटर्स हैं। तो जब आपने टाइम को एक्सपेंड किया तो फ्रीक्वेंसी में क्या करोगे, कॉम्प्रेस। बिल्कुल सिंपल वर्ड्स में बता रहा हूँ। ठीक है, तो आपने टाइम डोमेन में डबल एक्सपेंशन किया है, क्योंकि जब आप वेरिएबल टी को t/2 से रिप्लेस करोगे तो टाइम एक्सिस को 2 से मल्टीप्लाई करना होगा। तो टाइम डोमेन में जो भी सिग्नल का ड्यूरेशन होगा वो डबल हो जाएगा, क्योंकि टाइम एक्सिस को आपको 2 से मल्टीप्लाई करना पड़ेगा। तो टाइम डोमेन में सिग्नल का ड्यूरेशन डबल होगा, तो फ्रीक्वेंसी डोमेन में सिग्नल का ड्यूरेशन क्या होगा, हाफ। मतलब फ्रीक्वेंसी डोमेन में स्पेक्ट्रम क्या होगा, हाफ। फ्रीक्वेंसी डोमेन में स्पेक्ट्रम हाफ होने का मतलब जो भी मैक्सिमम फ्रीक्वेंसी कंपोनेंट है उसे हमें क्या करना होगा, हाफ। तो अब मैं मैक्सिमम फ्रीक्वेंसी कंपोनेंट क्या लिखूँगा, 5 किलो हर्ट्ज। ठीक है, अब इसके बाद ये जो रिलेशनशिप है इसे मैं यूज़ कर लेता हूँ। So from equation number 1, so what is equation number 1? It is like this, yt is equal to x of t into x of t by 2 plus 1। आपको एक चीज़ याद रखनी है कि टाइम डोमेन में अगर सिग्नल्स मल्टीप्लाई होते हैं तो उनके मैक्सिमम फ्रीक्वेंसी कंपोनेंट्स ऐड हो जाते हैं। तो यहाँ सिग्नल्स मल्टीप्लाई हो रहे हैं तो इनके मैक्सिमम फ्रीक्वेंसी कंपोनेंट्स को आपको क्या करना होगा, ऐड। फॉर फर्स्ट टर्म मैक्सिमम फ्रीक्वेंसी कंपोनेंट इज 10 किलो हर्ट्ज। फॉर सेकेंड टर्म एक्स ऑफ टी बाई 2 प्लस 1, इसका मैक्सिमम फ्रीक्वेंसी कंपोनेंट कितना, 5 किलो हर्ट्ज। अब मुझे वाई के लिए मैक्सिमम फ्रीक्वेंसी कंपोनेंट लिखना है, तो मुझे मैक्सिमम फ्रीक्वेंसी कंपोनेंट लिखना है वाई के लिए। क्या करूँ मैं, इन दोनों के मैक्सिमम फ्रीक्वेंसी कंपोनेंट को क्या करूँगा, ऐड। इन दोनों के मैक्सिमम फ्रीक्वेंसी कंपोनेंट को ऐड करो तो कितना आया, 15 किलो हर्ट्ज। अब नेक्विस्ट रेट कैलकुलेट करना है सिग्नल वाई के लिए। कैसे कैलकुलेट करोगे, तो जो भी वाई का मैक्सिमम फ्रीक्वेंसी कंपोनेंट है उससे आप डबल कर लो। तो वाई का मैक्सिमम फ्रीक्वेंसी कंपोनेंट कितना है, 15, डबल करो आंसर कितना आएगा, 30 किलो हर्ट्ज। तो आप लिखोगे 2 इंटू मैक्सिमम फ्रीक्वेंसी कंपोनेंट ऑफ सिग्नल वाई टी, सो 2 इंटू 15, आंसर कितना आया, 30 किलो हर्ट्ज। क्वेश्चन आपको समझ में आया होगा, ठीक है। अब इसके बाद नेक्स्ट क्वेश्चन के लिए हम लोग प्रोसीड करते हैं। क्वेश्चन नंबर 3 सिग्नल से रिलेटेड है और कुछ इस फॉर्म में है। फॉर इनपुट x1n इज u ऑफ n, आउटपुट ऑफ LTI सिस्टम इज y1n and y1n is equal to 2 delta n plus 1 plus delta n plus delta n minus 1, ठीक है, इस फॉर्म में है। फिर सेकेंड डाटा क्या है, फॉर इनपुट x ऑफ n वेर x ऑफ n इज 1/2 की पावर n un, सिस्टम का आउटपुट सपोज y ऑफ n है। तो हमें कैलकुलेट करना है y ऑफ n n इक्वल टू 0 पर कितना होगा। क्वेश्चन क्लियर है। तो x1 n के लिए y1 n गिवन है सिस्टम का, और x ऑफ n एक नया इनपुट है, इसके लिए जो भी सिस्टम का आउटपुट मिलेगा उसका सैंपल लिखना है n इक्वल टू 0 पर। तो दोस्तों बहुत सिंपल है ये। यहाँ पर अब मैं अगर इस फॉर्म में कहूँ तो सिस्टम का स्टेप रेस्पॉन्स गिवन है, और नेक्स्ट इनपुट के लिए आपको जो भी रेस्पॉन्स आएगा, आउटपुट आएगा, वो n इक्वल टू 0 पर लिखना है। तो इसे आप इस फॉर्म में लिख दो, y1 n के सैंपल्स लिखो तो आप क्या लिखोगे, 2 1 एंड 1। ओरिजिन में कहाँ लोकेट करूँगा, सेकेंड एलिमेंट पर, क्योंकि डेल्टा n का मतलब है सैंपल वैल्यू 1 एट ओरिजिन। ठीक है। अब अगर आपके सामने स्टेप रेस्पॉन्स गिवन है और आपको इम्पल्स रेस्पॉन्स कैलकुलेट करना है, तो कैलकुलेट तो कर सकते हो। हम लोग यहाँ से क्या कैलकुलेट करेंगे, सिस्टम का इम्पल्स रेस्पॉन्स। और बहुत ही आसान तरीका है, सिस्टम का इम्पल्स रेस्पॉन्स कैसे कैलकुलेट करोगे, सक्सेसिव डिफरेंस ऑफ स्टेप रेस्पॉन्स। तो स्टेप रेस्पॉन्स के सक्सेसिव डिफरेंस से क्या मिलेगा, सिस्टम का इम्पल्स रेस्पॉन्स। तो आप लिखोगे y ऑफ y1 n माइनस y1 n माइनस 1। ठीक है। तो पहले y1 n के सैंपल्स लिखो, फिर जो भी y1 n के सैंपल्स आएंगे उसको 1 से राइट शिफ्ट कर देना, और y1 n में y1 n माइनस 1 के सैंपल्स सेपरेट कर लो, तो किसके सैंपल्स मिलेंगे, h ऑफ n के सैंपल्स मिलेंगे। फटाफट ये कैलकुलेशन हम लोग करते हैं। तो y1 n के सैंपल्स में क्या लिखूंगा, 2 1 1। ओके। मान लो इसके बाद अगर सैंपल लिखना है तो मैं क्या लिखता, 0। अब इसे आप राइट शिफ्ट करो। याद रहे जब आप राइट शिफ्ट करोगे तो एरो का पोजीशन फिक्स्ड है, सैंपल्स को आपको 1 से राइट शिफ्ट करना है। तो एरो का पोजीशन फिक्स्ड है, सैंपल्स को आप 1 से राइट शिफ्ट करो, तो आप लिखोगे 0 2 1 1। अब आप इन दोनों को क्या करोगे, सब्ट्रैक्ट करोगे तो क्या मिलेगा, इम्पल्स रेस्पॉन्स h ऑफ n। h ऑफ n के सैंपल्स फटाफट लिखो, क्या लिखोगे, 2 माइनस 1 0 एंड माइनस 1। तो h ऑफ n के सैंपल्स मिल गए, सिस्टम का इम्पल्स रेस्पॉन्स मिल गया, सिस्टम का न्यू इनपुट गिवन है तो न्यू आउटपुट कैलकुलेट करना है। अब सिस्टम का न्यू आउटपुट y ऑफ n चाहिए हमें, कैसे कैलकुलेट होगा, सिस्टम के न्यू इनपुट x ऑफ n को, सिस्टम के न्यू इनपुट x ऑफ n को सिस्टम के इम्पल्स रेस्पॉन्स के साथ क्या करोगे, कन्वॉल्व। ठीक है। ओके। अब इसमें आप क्या करो, x ऑफ n के सैंपल्स एक बार लिखो, x ऑफ n 1/2 की पावर n un है, तो ऐसे सैंपल्स के फॉर्म में लिखो। तो n के वैल्यूज को 0 1 2 3 4 पुट करते जाओ, n को 0 पुट करो 1, इस फॉर्म में आएंगे। मैंने क्या किया, बस केवल x ऑफ n के सैंपल्स लिखे, n को 0 1 2 3 पुट करके। ठीक है। x ऑफ n के सैंपल्स मालूम है, h ऑफ n के सैंपल्स मालूम है। अब अगर y ऑफ n के सैंपल्स चाहिए तो कन्वोल्यूशन से कैलकुलेट करना होगा। कन्वोल्यूशन कैलकुलेशन का आसान तरीका क्या है, टेबुलर मेथड। रो में x ऑफ n के सैंपल्स लिखो, कॉलम में h ऑफ n के सैंपल्स लिखो। x ऑफ n के सैंपल्स क्या है, 1 1/2 1/4 एंड सो ऑन। h ऑफ n के सैंपल्स हमने अभी कैलकुलेट किए हैं, 2 -1 0 एंड -1, 2 -1 0 -1। कॉलम के सारे सैंपल्स को रो के सारे सैंपल्स से मल्टीप्लाई करो, फटाफट कैलकुलेशन करो। तो आप लिखोगे 2 1 2 इंटू 1/4 कितना, 1/2 एंड सो ऑन। फिर -1 से सबको मल्टीप्लाई करो, -1 -1/2, फिर -1/4 एंड सो ऑन। 0 से मल्टीप्लाई करो, 0 0 0 एंड सो ऑन। फिर -1 से मल्टीप्लाई करना है तो कर लो, फिर इसी तरह लिखना होगा, फिर -1, फिर -1/2, फिर -1/4 एंड सो ऑन। इस फॉर्म में लिखूंगा। अब इसके बाद आप डायगोनल एरोज ड्रॉ करो। तो मैं थोड़ा दूसरे कलर से ड्रॉ करने का ट्राई करता हूँ, कुछ इस फॉर्म में ड्रॉ कर देता हूँ। ओके। अब जो भी डायगोनल एरोज आए हैं, एरो के डायरेक्शन में जो भी एलिमेंट हैं सबको ऐड करते चलो, और y ऑफ n के सैंपल्स लिख डालो। तो y ऑफ n के सैंपल्स लिखे हम लोग, फर्स्ट एरो 2 से पास हुआ तो फर्स्ट एलिमेंट है 2, सेकेंड एरो 1 और -1 से पास हुआ, 1 -1 को ऐड कर लो। एरो के डायरेक्शन में जो भी एलिमेंट चार्ट के इनसाइड है उसको क्या करना है, ऐड। तो 1 और -1 को ऐड करो, कितना। फिर थर्ड एरो के लॉन्ग ऐड करो, तो 1/2 -1/2 0 ऐड करो, कितना। फिर फोर्थ एरो के अलॉन्ग ऐड करना, ऐड करो। ठीक है। अब मैं फर्दर कैलकुलेशन नहीं कर रहा हूँ क्योंकि अपना आंसर आ चुका है। किस तरह आया, थोड़ा ध्यान दो। HN का स्टार्टिंग पॉइंट, HN कहाँ से स्टार्ट हो रहा है, n इक्वल टू -1 से। क्यों? ओरिजिन का एलिमेंट -1 है और एरो सेकेंड एलिमेंट पर है, तो ये स्टार्ट कहाँ से हुआ? ये स्टार्ट कहाँ से हुआ? n इक्वल टू -1 से। स्टार्टिंग पॉइंट बता रहा हूँ, एक्सन का फर्स्ट एलिमेंट ओरिजिन पर मिला, तो एक्सन स्टार्ट कहाँ से हुआ? n इक्वल टू 0 से। इन दोनों के स्टार्टिंग पॉइंट को ऐड कर लो, रिजल्ट का स्टार्टिंग पॉइंट मिल जाएगा। तो इसका स्टार्टिंग पॉइंट -1 है, ये स्टार्ट हो रहा है n इक्वल टू 0 से। दोनों का स्टार्टिंग पॉइंट ऐड करो, कितना आया? -1 प्लस 0, -1, मतलब y स्टार्ट होगा n इक्वल टू -1 से। तो y कहाँ से स्टार्ट होगा? n इक्वल टू -1 से। तो मेरे दोस्तों, अगर ये n इक्वल टू -1 का एलिमेंट है, तो ये कहाँ का एलिमेंट है? n इक्वल टू 0 का। इसलिए मैंने सेकेंड एलिमेंट पर क्या लोकेट किया? 0। तो आप यहाँ से देख करके बता सकते हो y ऑफ 0 की वैल्यू कितनी है? 0। ठीक है। तो जितने भी क्वेश्चन मैंने सॉल्व किए, ये सारे क्वेश्चंस जो क्लास कंटेंट मैंने सॉल्व कराया था उससे काफ़ी हद तक रिलेटेड है। एक क्वेश्चन तो बिल्कुल सिमिलर है, तो आप उसको भी फॉलो करते तो ये सारे क्वेश्चन इजीली अटेम्प्ट कर लेते। अब इसके बाद नेक्स्ट सब्जेक्ट के लिए हम लोग प्रोसीड करेंगे।
Hello everyone, I am Aditya Kamal. I am going to deal with the questions that have been asked in the GATE exam today in ECE in the electric circuits. Okay, so in network theory or in electric circuits, the questions that have been asked, these are we have reproduced this based on the memory of the students actually. So these are the memory based questions. If there is any discrepancy, that will be rectified when the GATE will be giving us the main questions at that time. So we will be rectifying all the things, but based on the memory whatever we have gathered, based on that we are doing the questions actually. So this is the first question that we have over here. We have to find the value of the voltage V0 in this question. So see what we can do in this question, we have to find V0. So what will be the current flowing over here? V0 upon 1K, can I write it V0 milliampere? 2 is coming from here, V0 is coming from here, current in this will be V0 plus 2 milli. Let's apply the KVL in this. So if I apply the KVL in this loop, what I will be getting? Minus 4 plus V0 plus this current into 1K. So millivert get cancelled. I'll be having V1, V0, sorry, this is V0 plus 2 is equal to 0. So from here you can see 2 V0 is coming equal to 2, or V0 is coming equal to 1 volts. So this is the first question that we had over here. Let's move on to the next question. This is the next question that we have. In this question they have asked us to calculate the value of current I. This is what we have to calculate. So see, I can redraw this network by taking this 7 from outside. Instead of drawing it like this, I can draw it like this. What I am talking about is this. Have a look at this. The 7 which was from here, I have drawn it from here. Now you can easily notice 6 and 3 are connected in parallel. So we can write it as 6 and 3 in parallel. What do we get? 2 ohms. Then 2 and 2 in parallel. What we get? 1 ohm. And with 1 ohm we will be having 5 ampere connected over here. And then we have 7 ohm connected from outside, and current I is flowing from here. We can go with the current division rule because this and this branch all are connected in parallel. Therefore, the current I, this will be equal to 5 divided by 7 plus 2 9, 9 plus 1 10. We want in this branch, so multiplied by 1. So 5 by 10, that is 1 by 2, or 0.5 ampere is our answer for this question. Moving to the next question that they asked. This is the question that they have asked, and in this question what they have asked, they have asked us to calculate the Y parameters. Okay, so we have to calculate the Y parameters in this case. So we can easily handle this question if we go with the equation method, that is we are going to apply the KCL at input and output side. So if I apply the KCL at the input side, current I1 will be equal to V1, because this node voltage will be V1. So V1 divided by 1 plus V1 minus V2 divided by 1 divided by 1, 3 V2. So I'll be writing it as minus 3 V2. Okay. So V1 by 1 outgoing, V1 minus V2 by 1 outgoing, minus 3 V2 because it is incoming. So you can see I1 here, this is coming as V1 plus V1, that is 2 V1, minus V2 minus 3 V2, that is minus 4 V2, equation number 1. If you would have checked the options, it was better to go with the output side because the options were different for all the cases. In case of Y1 and Y2, the options were same approximately. So let's go for the output side. I2 will be equal to V2 by 1 plus V2 minus V1 by 1, V2 minus V1 by 1. So this is the current I2. So I2, if you check, this is coming as minus V1 plus 2 V2. So from here you can see the Y parameter metrics are Y11, Y12. You can compare it accordingly. This is coming as 2, minus 4, minus 1, 2. So these are the Y parameters that they asked us in the question. Moving to the next question. In this question, the information that has been given is that the circuit shown in the figure, which is closed at t equal to 0 while the capacitor initially charged to minus volt. What he has given that initially the voltage on the capacitor was minus 5 volt. So can we say that Vc0 plus, which is same as Vc0 minus, this is given as minus 5 volts. Now he is saying that the time after which the voltage across capacitor becomes 0. He is saying that we have closed the switch. Now how much time it will take so that the voltage across the capacitor goes to 0? Why? Because the DC source is connected, so in the steady state it's going to be 0 volt. It's going to be 0 current because it's going to be open. So that's the information that he's asking us, that how much time it will take after which the voltage across the capacitor is becoming 0. So let's check it out. So for that, first we will have to calculate the voltage. Okay, first we will have to calculate the voltage across the capacitor, that is Vc of t. So let's have a look. We want to find Vc of t. You know that when the switch is closed, the formula for the voltage that we are going to get will be final value plus initial value minus final value e to the power minus t by tau. Okay. Initial value we have already calculated. Now we are interested in calculating the final value. When we will calculate the final value, so in the steady state it will be replaced by an open circuit. So replacing it by an open circuit, this is the circuit that will be having plus minus 5 volts. We have a resistor over here, a dependent source, again a resistor, switch is closed, and this will be replaced by an open circuit. The value here is 250 plus minus VR, this is VR divided by 500, this is 250 ohms. Okay. So the switch is closed, the circuit is in steady state, so this is open, and we are interested in calculating this voltage Vc. This is the steady state calculation that we are doing. Now apply the nodal, it will be Vc minus 5 by 250 plus VR by 500 plus Vc by 250, and then VR will be equal to minus Vc. By doing so you will getting the value of Vc, because I am not wasting time in that. Vc that we are going to get is coming as Vc infinity, because solving at t equal to infinity, this is coming as 5 by 3 volts. So this is the final value that we have got. Initial value we have now, final value we have now. What we are interested is in the time constant. So what is time constant? So in case of an RC network, the time constant is R equivalent into C. What will be R equivalent? R equivalent will be the equivalent resistance seen between the terminals of the capacitor. So I have replaced the voltage source by a short circuit. This is VR by 500, 250 ohms. And now, as the dependent source is present, for the calculation of R equivalent, you can either connect a voltage source or a current source, it is on you. So the equivalent resistance that we will get will be 1 upon I. So I hope again you can solve this question, just apply the nodal or KCL, and you can see this time 1 1 VR will be minus 1. So you can easily do the calculation. After doing the calculation, the equivalent resistance comes out to be equal to 500 by 3 ohms. So R equivalent we have calculated. So now the time constant will be R equivalent into C, that is 500 divided by 3 into C. C value we have 0.6 micro, and in solving this, this comes out to be equal to 0.1 into 10 to the power minus 3 seconds. So this is the time constant that we have got. If we substitute the whole information in Vc of t, Vc of t is final value, which is 5 by 3, minus initial value was minus 5, final value minus 5 by 3, e to the power minus t by tau. So tau is 10 power minus 4, so we can write it as 10 power 4 t. And on solving this, we will get something, but what we are interested is in the time at which the voltage across the capacitor becomes 0. So let's make it 0. 0 will be equal to 5 by 3 minus 5 by 3 t to the power minus 10 to the power 4 t1, and we can solve this expression. And on solving this, the time t1 at which the voltage across the capacitor is becoming equal to 0, this is 0.1386 milliseconds. So calculation you can do. So you can see the time at which the voltage across the capacitor is becoming equal to 0 is 0.1386 millisecond. Let's move on to the next question. This was the next question they have given. A lot of information were given in the question, but the only important information that we can take from this question is this. The switch means initially the capacitor is unenergized, okay, there was no reading in the ammeter. So when the switch is closed, okay, the current or the reading of the ammeter fluctuates for some time. Now he is saying that the maximum ammeter reading that one will observe after the switch is closed. You know, when the switch is closed, what is the maximum ammeter reading that we can have? So let us find the current expression. For that I am taking it to the Laplace domain. Why? RLC network shortcut formula we cannot apply, because that can be applied either for RL or for RC, but not for the RLC. So if we take it to the Laplace domain, this is the circuit that I will be having. 1 can be replaced by 1 by S, switch is closed, capacitor 1 by Cs, as it was initially unenergized, so no voltage source or a current source. Ammeter is ideal, 0 resistance. R SL. Let us solve it in terms of unknown variable and then we will put the values. So let us apply the nodal, because I want to find the current flowing through it. Okay. For that I am saying that let us find this node voltage. Let us say the node voltage is V1 of S. You can apply the nodal. 1 by S is equal to V1 of S upon 1 by Cs plus V1S upon R plus SL. After solving that, V1S, this is coming equal to 1 by S into R plus SL divided by LC S square plus RCS plus 1. We have got V1 of S, but what we are interested is in calculating I of S. So what will be I of S? I of S will be equal to V1S upon R plus SL. So let us divide it by R plus SL. So what I am left with is this 1 upon S into LCS square plus RCS plus 1. This is what we have got. Now the wording, if you see, the current fluctuates for some time before settling down. Seems like an underdamped response, isn't it? Maximum value he wants us to calculate. So let us first calculate the zeta value. Let us see how much zeta is coming. So if you see, zeta is going to be R by 2 under root of C by L. If we substitute the values in this, let us see what is zeta that we are getting. Zeta is coming as 0.25 as expected underdamped system. Zeta we have calculated. Let us calculate the maximum percentage overshoot value. Why? Because if you know the steady state value and if you add the overshoot, you will get the answer, or we will use the formula. I will show you. So let us see the maximum percentage overshoot. How much it is coming? It will be e to the power minus pi zeta upon under root of 1 minus zeta square into 100, because we are going for the first overshoot as we need the maximum value. So after solving this, if you put the zeta value over here, this comes out to be 44%. Now you know that the maximum percentage overshoot, if you write, can I write the basic formula as CT maximum minus CT desired or CT steady state, whatever you want to write, C of t, this is the final value that it will be settling to, upon C of t desired into 100 is the maximum percentage overshoot. How much we have got? 44. What will be the value that it will be settling? CT is current over here. I am using the control system formula. CT is the response is the current. So if you see in this case, the desired, the final value will be limit s tending to 0. Let me write I of t final value. Okay, it will be limit s tending to 0, s I of s cancelled, 0 0 1. If you substitute it over here, can you see C of t maximum, that is I of t, okay, will be equal to minus 1 is equal to 0.44, or the maximum value of C of t, which is the current actually that we are calculating. This is coming as 1.44. So this will be the maximum value the current will be having. Okay, so these were the questions that were asked in the network theory in the GATE examination. I have solved them for you. So that was all from my part.
Hello friends, I am Dheeraj, your faculty for reasoning and aptitude, and today नहीं आया, स्लाइड नहीं है. Hi students, I am Dheeraj, your faculty for reasoning and aptitude. Your faculty for reasoning and aptitude, and today we are going to discuss the questions which have come in GATE 2021 Electronics and Communication Engineering ECE. So these are the questions which you have received from the students on a memory base. So the first question was something like this, that we have if P plus Q is equal to 3, what is the value of let me see the question completely. It is P by Q plus Q by P is equal to 3, then what is the value of P square by Q square plus Q square by P square? It is a very simple thing, just make a whole square of it. तो आप इसे whole square कर दीजिए, that is equal to 3 square. Now this is P by Q whole square plus Q by P whole square plus 2 into P by Q into Q by P. So that is equal to 9. तो ये आसानी से आ जाता है, is equal to 9 minus 2, that is equal to 7. So 7 will be the answer for this question, right? So we don't know whether it is NAT question or MCQ question, but the answer will be 7. Now यहाँ पे देखिए next question. There is the current population of a city is given. It is 11,200,500, and there is a growth, annual growth every year. The annual growth is 5% every year, and he has given the current population, and he was telling what was the population of that city 2 years ago. That means he has given the present population and the growth rate is 5% per annum. तो इसका मतलब मान लीजिए initially the population was some x, तो 5% increase होने के बाद what will be the resultant? So 105 by 100, again 2 years into 105 by 100 is equal to 11,02,500. तो इसे x का वैल्यू पूछ रहा है वो. तो he has given the population, current population, and he has given what was the population 2 years before. So he is asking the population in the beginning. So x is equal to 11,02,500. So 100 by 105 into 100 by 105. तो इसे simplify कर दीजिए, आपको आंसर मिल जाएगा 10 लाख. So 10 lakh or 1 million is the answer for this question. I hope you are checking the answers. Now we will go to the next question. It is a syllogism question. There is a syllogism question. The statements are given something like this: all purple are green, all black are green. So I think if anyone have watched my classes, so definitely you will be knowing how to draw logical Venn diagrams. All purple are green. So all purple are green, all black are green, all black are green. We know this. This is not the only diagram, because conclusions भी आप देख सकते हो. Some black and purple के बारे में questions पूछे गए, conclusions दिए हुए. So that there is no rule that these two should be separate. ये ऐसे भी हो सकते हैं. तो थर्ड डायग्राम आप ड्रॉ कर सकते हो. ये ऐसे भी हो सकते हैं, पर्पल एंड ब्लैक, या फिर ये ऐसे भी हो सकते हैं. Okay, there are 4 possible diagrams that can be drawn, right? So now we will go to the conclusion. Some black or purple. Some black or purple. Conclusion 1. Some black or purple. Some black or purple. That means black and purple have some connection. The first diagram is not agreeing, but the second diagram is agreeing. Third diagram is supporting. Fourth diagram is supporting. So there is some diagrams are agreeing, supporting it. Some diagrams are not agreeing it. तो ये नो डेफिनेट कंक्लूजन केस में चला जाता है, या फिर अनसर्टेन केस में चला जाता है, या फिर मे और मे नॉट बी कंडीशन में चला जाता है. C2, what is conclusion 2? No black or purple. no black or purple, that means black and purple does not have any link to each other. The first diagram is agreeing for it, but second diagram is not supporting, third diagram is not supporting, fourth diagram is not supporting. You know, if a conclusion needs to be 100% correct, every diagram should support it. If a conclusion needs to be 100% wrong, every diagram should reject it. So this also goes into no definite condition, no definite conclusion. So either, that means clearly according to the rules, you have watched my classes, so you know very well. So first of all we are talking only about two elements here, black, purple, black, purple. Second condition क्या था? Some and no condition. The discussion is only about two things, and one conclusion has some as prefix and another conclusion has no as prefix. That means this goes into positive domain and this goes into negative domain. And the third condition is both comes under NDC conditions. तो इसका आंसर क्या हो जाता है? Either C1 और C2 follows में आ जाता है. Either C1 और C2 follows में आ जाता है. Now the question is the number of days in a given week. These are the days in a week, all the 7 days are given to you. The number of days in a given week in which one of the students spends minimum of minimum of 10% more than the other. So minimum of 10% more than the other का मतलब होता है you have to take the minimum number and check whether the other number is minimum 10% higher or not. तो यहाँ पे ले सकते हैं 55 का 55. Let us take a color here. 55 का 10% क्या होता है? 5.5. So 55 plus 5.5 is, yes, it is clearly under 65 only. So this is okay. So 50 plus 5, yes, 55, 60 is more than, this is also okay. So 20 plus 2, 22, 35 is clearly more than 22, this is also okay. So now 55 plus 5.5. 55 plus 5.5 is equal to 60.5. ये नहीं आ रहा है. तो 55 plus 5.5 is 60.5. Yes, 65 is clearly greater than that. So 45 plus 4.5, 10% of 45 is 4.5, 70 is clear more than. That means only one day is not agreeing to the condition. Out of 7 days, only one day is not agreeing to the condition, minimum of 10%. So the number of days? 6 days. Out of 7 days, in 6 days, clearly one of the students spends minimum 10% more than the other students. So 6 is the answer for this question. Okay. Now we are going into the next question. ये बहुत ही interesting question ही है. There is a square whose dimension is 1 unit. So this is the question we got from the data. This is from the memory of the students. We don't know whether it is completely correct or not. So there is a square taken whose dimension is 1 unit or 1 centimeter, whatever. There is a diagonal drawn. When a diagonal is drawn to the square, triangle is formed. So they have taken this triangle and along a side or a height, you can take is, they have rotated it along a length or height of the triangle, and virtually there is a cone formed, something like this. There is a cone formed. So when you take something, there is a cone formed. My front position को दिखा रहा हूँ. This is also 1 unit. Base radius is also 1 unit. Okay. Let me check the question once. Yes. Now he is asking. So that cone that is formed. Now the square is taken and a diagonal is drawn and it is cut. The triangle part is taken and the triangle part is rotated so that virtually you can see that means a 2-dimensional figure is being converted into virtual 3-dimensional figure, which looks like a cone, a right circular cone. Okay. So he is asking what is the volume of that right circular cone formed. My dear friends, what is the formula for the volume of a right circular cone? 1 by 3 pi r square h. 1 by 3. So all the dimensions are 1 only. So base radius is 1, height is also 1. So definitely the volume will be pi by 3. Pi by 3 centimeter cube or meter cube, whatever it is. So pi by 3 should be the answer for this question according to the data we have received. Okay. So now we are going into the next question. This is also a beautiful question based on geometry. There is a hexagon and an equilateral triangle. This is an equilateral triangle, and inside there is a hexagon constructed, and he is asking, there is a regular hexagon constructed by using the sides of the equilateral triangle. Okay, so he is asking what is the ratio between the area of this triangle and hexagon and triangle, I think so. First of all, why he is asking this question, you have to know a regular hexagon is nothing but a combination of, here clearly I will draw it here, a regular hexagon is nothing but combination of 3 equilateral triangles, sorry 6 equilateral triangles. 6 equilateral triangle combine होने से आप एक regular hexagon पा सकते हो. You can get a regular hexagon by combining 6 equilateral triangles. And अब equilateral triangle कैसे बनेगा? You can flip something like this, and you can flip this triangle something like this, and you can flip this triangle something like this, and you got an equilateral triangle. तो यही आपसे he wants to check whether you know this trick or not. So completely here already 6 are there, 1 2 3 4 5 6. So 3 more triangles, 3 more equilateral triangles are formed, क्योंकि इसी का आप flip कर रहे हो. तो 7th one is here, 8th one is here, 9th one is here. So that means you can take this whole figure as 9 equilateral triangles. Okay, so 9 equilateral triangles, he is asking the ratio of what? He is asking the ratio of area of hexagon and triangle. Hexagon के area आप 6 ले सकते हो, and पूरा triangle 3 extra triangles are there, 9 equal smaller triangles, and the ratio will be 2:3. That means this 6 represents hexagon and this 9 represents triangle. अगर आप reverse में पूछते तो what is the ratio of the angle of triangle and the hexagon? 3:2 answer होगा, but this is the data we have received. So the answer will be 2:3 for this question. He asked you this is a beautiful question. Hexagon is nothing but a combination of 6 equilateral triangles, and when alternate equilateral triangles, ये वाला or this one and this one, when alternate equilateral triangles in that regular hexagon is they are flipped to their axis, to their point, you will get an equilateral triangle. ये बहुत ही important point है, ये check करने के लिए आपसे ये question पूछा होगा. So to test your knowledge in geometry. So EC questions are very interesting. So transformational geometry, that means transforming one figure into one 2D figure into another 2D figure, 2D figure into 3D figures. So इसे बोलते हैं transformational geometry. Some interesting questions are given in the aptitude section of electronics and communication. Now these are the questions that we have received. I hope you all checked your answers, and our next eminent faculty will continue the session. Thank you.
Hello dear students, welcome to the solution of EMT. So all these questions will be memory based for electronics and telecommunication, right? Now the first question that we have, see, an antenna with a directive gain of 6 dB is radiating a total power of 16 kilowatt. The amplitude of the electric field in free space at a distance 8 km from the antenna in the direction of 6 dB gain is what? See, how to solve this question? So let us solve this question. See, this question was from antenna. Now what are the data that has been given? See, in dB, how much it is given? So it is given as 6 dB, right? Okay, and what is the power radiated? It has been given in the question. So it is 16 into 10 to the power 3 watt, right? Fine. Now further what they are asking? They are asking what is the magnitude of the electric field at a distance of 8 kilometers. So that means 8 into 10 to the power 3 meter, right? So this is the thing that we have to find. So this is the thing that we have to find the electric field. Now we know that what is P average. See here, it is a very simple question. P average mod of E square upon 2 eta. Now this can be also written as GD into P radiation upon 4 pi r square. Right. Now this GD, now it is in dB, it is given, we have to put in GD. So therefore, how to convert dB? So GD in dB, it is equal to 10 log base 10 GD. So this is given as 6 is equal to 10 log 10 GD. So what is the value of GD? GD is equal to 10 to the power 0.6. So how much it is? So using calculator we will get 3.98. Right. So this is the thing that we have got. Now we have got everything. Now we have to find E. So therefore what is E? Mod of E. It is equal to. Now you can see that this 2, this is getting cancelled. So we can write it as GD into P radiation eta upon 2 pi r square root under. So as simple as this. So just put the values. What is GD? We are getting 3.98. What is P radiation? So P radiation, it is given as 16 into 10 to the power 3. I am just putting the value. And what is eta? So it, since in the question it is given as free space. So if you read the question, in the question they have clearly mentioned it is the free space. Right. So it is given free space. Sorry. This is given as free space. Right. So therefore, what will be the value of eta for free space? It is 120 pi, we know that. This is divided by 2 pi, and what is the distance they have given? So 8 kilometer, right? So 8 into 10 to the power 3 whole square. So if you solve it, you will get 0.244 volt per meter. So this is the NAT. So we will get this answer. Fine. So this is the answer for the question which was asked in from the antenna. Now coming to the next question. So all the questions are memory based. Fine. So I am doing the solution according to the question that we have got from the students. Now another question, a vector field D is given, right? So how to solve the question? See what is given? D vector is given. It is given as rho of cos square phi in the direction of arrow plus z square sine of phi in the direction of a phi, right? Cylindrical coordinate system, obviously, but obviously it is cylindrical coordinate system with unit vector. Okay, the net flux D leaving the closed surface of the cylinder rho equal to 3. So closed cylinder. So how you can see? So see here. Suppose this is a cylinder, right? Let us say this is the cylinder, and let us say this is the z axis. Say this is the y axis, and say this is the x axis, right? So rho is equal to 3, it is given, right? So that means rho is constant. So what I can say over here is, if rho is constant, that means, let us say this is rho is equal to 3, right? So which will be the surface through which the flux is going to pass? Obviously you will get this surface. This is the surface. So what is the unit vector from this? Now this ds vector will be, how we can say that this is ds in the direction of arrow, right? So we have to find the flux now from here, right? Now how we know? Because here z value is given from 0 to 2. That means z is given from 0, z is given from 2. So that means which surface it is talking about? Rho equal to 3. So that means rho equal to 3. That means this surface which is changing from z equal to 0 to 2. So that means in the question they are asking this surface. So we have to consider this surface, right? So therefore what will be the value of ds? ds. Now we know that there are two methods to find this ds that we have already discussed in the class. So how we can find ds? So if I use the graphical approach, we can directly find. Fine. So if I do the graphical approach, so what will be d dot ds? What will be ds? Now what will be this value? 1 second. So this value will be how much? Now this is your rho of d phi, and this will be your dz, right? So what will be your ds vector? It will be your rho of d phi dz in the direction of arrow, right? Because the unit vector is in the direction of arrow. Right. Now if I use the analytical approach, what is analytical approach? If I use analytical approach, so what is analytical approach? Analytical approach, what is that? We have u, v, w, h1, h2, h3, rho, phi, z 1 row and 1. Now here what is constant? See very careful how to use this. We have given rho is equal to 3. In the question it is clearly mentioned that you have to take the surface whose rho is equal to 3. So that means rho is equal to 3. So what I have to do? I have to freeze this one, right? Freeze this one. So what are the surface you are going to get? So this thing we already discussed. So ds vector, it is equal to rho d phi dz in the direction of arrow. See, you are getting here same ds rho d phi dz in the direction of arrow, right? So you can take any method to find the ds value. So what is the ds value I am going to get? I am going to get rho d phi dz in the direction of arrow. So what is the flux? D dot ds. Now D has both arrow as well as a phi. So what is, if I do the dot product with ds, so only arrow dot arrow will exist, because a phi dot arrow, it will become 0. So what I am going to get? I will get surface integral rho square cos square phi d phi dz at rho value is given as 3. So in the question the rho value that has been given is equal to 3. So therefore now it is simple integration. So simple, this is equal to this 3. So this is 9 integration of cos square phi d phi. Since it is a cylinder, so phi will be from 0, again it will come to up to 2 pi, then only it will become a complete cylinder. So it will be 2 pi integration of dz, sorry, integration of dz, and from where? Z is from 0 to 2. So Z is from 0 to 2, right? So let us solve it. So after solving it, how much you are going to get? You will get 18 pi, right? So it is a simple integration. If you solve it, you will get the answer as 18 pi. So this is one question. Another question that was asked, a standard air-filled rectangular waveguide with dimension A and B is given, operated at 3 gigahertz. For the dominant mode of wave propagation, the phase velocity of the signal is Vp. The value of Vp upon C is what? Right. So how to solve this question? Now see, this is a simple question. Let us see how to solve this question. What is phase velocity? Vp, it is equal to C upon root under 1 minus Fc upon F whole square. So they are asking Vp upon C. So Vp upon C is equal to 1 upon root under 1 minus Fc upon F whole square. Correct? Fine. Now we have to find, now F is given 3 gigahertz. In the question this F is given as 3 gigahertz. Now we have to find this Fc, right? So how to find this Fc? So if you look at, okay, no, it is given 3.4, sorry, it is given as 3.4 gigahertz. It is given as 3.4 gigahertz. Now how to find this Fc? Now in the question it is said that for the dominant mode. So what is a dominant mode? Dominant mode is T10. So therefore cutoff frequency for 10 mode, it is how much? We know the direct formula. I will write C upon 2 m upon A whole square plus n upon B whole square, right? So 10, if I substitute, what we are going to get? So I will get C upon 2A, right? So let us substitute the value. C is equal to 3 into 10 to the power 8 2. What is the dimension given? So dimension it is given as 8 centimeters. So 8 into 10 to the power minus 2. So what is the value you will get? I'm writing directly the value 875 gigahertz, right? So when you solve it, you will get this value. Now the question becomes very simple. So what I have to do? So therefore Vp upon C 1 upon root under 1 minus, what is Fc we have got? 1.875 divided by 3.4 gigahertz, right, whole square. So if you solve it, you will get 1.198. So when you are going to solve it, you will get, what is the answer you will get? You will get 1.198 is the answer you will get, right? So this is the answer for the question number 3. Now question number 4. Question number 4. The refractive indices of the core and cladding of an optical fiber are 1.50 and 1.48 respectively. The critical propagation angle, which is defined as the maximum angle that the light beam makes with the axis of the optical fiber, is achieved. The total internal reflection is what, right? So this is what we are going to solve. तो देखिए इसको कैसे solve करेंगे. So this question can be solved in two ways. So method 1, we know that, okay, directly we can write, so theta p, it is equal to sine inverse root under n1 square minus n2 square upon n1, right. So here it is equal to sine inverse. So what is your n1? So if you look at n1, it is your, sorry, root under 1.5 whole square minus 1.48 whole square divided by 1.5. So that formula based question. So if you solve it, you will get answer as 9.36 degree, right. So this is one method to solve this question. Now another method we can take, method 2, theta p can be written as cos inverse. Now what is the value? Minimum value is given as 1.48 and this is a 1.5. So if you solve it again, you will get the same answer, 9.36 degree. So this is the answer for this question. Fine. I hope it is clear. Okay. Next. So this is the last question that we have received from the memory based. So consider these are all memory based, right. So consider rectangular coordinate system xyz vector is given, a plane wave traveling in the region z greater than 0 with electric field is something is given, is incident normally on the plane z equal to 0 where beta is the phase constant. The reason z greater than 0 is in the free space and the reason z less than 0 is filled with lossless medium whose permittivity and permeability is clearly given. The value of the reflection coefficient. So it is very simple question, a very basic question. So how to solve this question? See, say this is your z equal to 0 interface given, this is z greater than 0 and this is z less than 0, right. Now what the question is saying, this is your free space, this is your free space. So that means, and the electric field E in this medium, it is given as 10 cos 2 into 10 to the power 8 t plus of beta z ay, right, beta z ay, beta z ay, it is given, right. Now it is said that the wave is incidenting normally at the interface, right. So it is said that the wave is incidentally normally on the z equal to 0 plane, right. So if it is free space, what does this mean? This means that its eta will be how much? It will be 120 pi, correct. So this is your 120 pi. Now the second medium, it is say that epsilon value is given as epsilon naught and mu value is given as 4 times mu naught. So what will be the value of eta? Let us say this is eta 1, eta 2. So we know that eta 2 is equal to 120 pi root under mu r upon epsilon r, right. So because there is some medium involved, so what will be this value? So this is 120 pi into epsilon r is 1, so this is 2. So this is how much? It is your 240 pi, right. Now they are asking what is the reflection coefficient. So what is the reflection coefficient? Tell. So reflection coefficient, it is equal to eta 2 because the wave is going to travel here minus the wave which is going to travel from the medium, eta 2 plus eta 1. So in which medium it is going to move? So 240 pi minus 120 pi divided by 240 pi plus 120 pi. This is how much? 120 pi upon 360 pi, 1 by 3. So what is the answer? Option C, according to the memory based, according to the question that has been given. So according to that we are getting 1 by 3. So answer is C. So this is all about the EMT. Thank you.
Hi students, I am Srikar Gupta. So today I am taking this GATE 2021 electronics engineering mathematics questions, and so these questions are little bit differently given, and थोड़ा सा the questions and questioning में थोड़ा सा अलग से हैं comparatively the previous examinations. So but let us see that how we are going to do the questions, and these questions to be frank, these questions have been taken on memory based. These questions are purely memory based questions. So some numbers may be getting changed, but maximum we have taken the proper things. So let us discuss the solutions of the GATE 2021 mathematics electronics engineering. Okay, now the first question here that is from the differential equation part. So it said that it's a differential equation is given, and find the integrating factor of it. Find the integrating factor of it. See, look at this. This is not a general linear integration, linear differential equation here. Okay. Now see, this is y to the power of half is given, right? So as this is a kind of Bernoulli differential equation, we say that this is a Bernoulli differential equation. Okay, this is a nonlinear equation, and this has to be reduced into linear equation, and then we have to find out the integrating factor, right? So how to reduce this one into linear of this Bernoulli differential equation? Let us see that. So dividing by this extra function, that is root y. So dividing by root y here. So then on both sides of the equation, then you are getting 1 by root y dy by dx, okay, and then minus x by 1 minus x square, and this one is y by root y, okay, is equal to x, we say that. And then see, this question is given. So actually it should be plus here, it should be plus. So let us see that it is plus, right? So now yes, after reducing this equation, this can be written as here 1 by root y dy by dx, okay, and this will be what? Root y it is. So plus x by 1 minus x square into root y is equal to here x, is equal to x here. Now still it is not in the linear differential equation. So हम यहाँ पर ये root y को अगर हम u मानते हैं तो उसका equation कैसे होगा, इसका solution कैसे लिख सकते हैं? Okay, let us take this root y is equal to u. Root y is equal to u, and the differentiation of this is 1 by 2 root y dy by dx is equal to du by dx. So these things we are going to substitute in this differential equation. So that is root y, okay, 1 by 2 root y. Here I can write this one term, this term as 2 into du by dx, okay, 2 into du by dx, and this will be as x by 1 minus x square, and this is u is equal to x here. But now the quotient of the du by dx should be 1 here, the du by dx should be here 1 it is. So therefore what we do is divide by 2, so du by dx, and this is plus 1 by 2 x by 1 minus x square into u is equal to x by 2, is equal to x by 2 here. This is what the differential equation, we got it. Yes, anybody give the answers from the above options? You can check it. Okay, but now here this is a linear differential equation, because this is completely, we can understand the p of x, right, and this is the q of x. So now the differential equation is of the form du by dx plus p of x into y, y is equal to x by 2 here. So यहाँ पर ये clearly linear differential equation है, ठीक है? So this is purely linear differential equation. So this is a linear differential equation. So once it is linear differential equation, the integrate, therefore the integration factor is given by e to the power of integral p of x dx, that is e to the power of integral p of x is this, that is 1 by 2 x by 1 minus x square dx here, right? So thoda sa integration, you have to be careful in doing the integration here. Okay. So this one, it is, see, e to the power of 1 by 2 outside, and if you multiply and divide by 1 by 2 here, and then it is 2x, but if it is written as this way, right, it is dx. So we can understand this is, it is e to the power of 1 by 4, and even minus you can take, because if you put minus here, then you have to multiply minus here. So then this is f of x, this is f dash of x. Integration of f dash of x by f of x is nothing but ln of f of x, right? So ln of f of x we are getting, so this is going to be log of 1 minus x square, log of 1 minus x square. So taking this one to the power of this, because it is a log, so this can be written as e to the power of log of 1 minus x square whole to the power of minus 1 by 4. Hence the if is written as here 1 minus x square whole to the power of minus 1 by 4, minus 1 by 4 here. So this is what exactly this answer. So for this question, so I think you can see that which options are there. See, option B is the right answer. 1 minus x square to whole to the power of minus 1 by 4, you are getting it. Okay, right? The level of somebody is asking about Rana. So what was the level of the question paper of ECE according to you? So the mathematics is little bit tough only. So because some questions are given little bit difficult, like that means the people who have attended the CTQ and regular course, so those people can understand, those people can do all the questions which is existing here. Because थोड़ा सा regular questions नहीं है ये, थोड़ा सा हटके दिया है कि थोड़ा सा twist है. So something you need to do more than the regular questions, than in the regular questions. तो ये बात है. So थोड़ा सा difficult है. So we can understand and you can, but sticking to the basics. So I think you can solve these questions here, right? So this is what this thing. So answer is here. Option B is the right answer. Option B is the right answer according to this, right? Okay. Now moving on to this next question here. Moving on to the next question, consider 2 by 2 non-singular matrix A here. So this is the matrix linear algebra question. So with repeated eigenvalues, please understand this repeated eigenvalues. Okay, this is a very important thing here. So this is a repeated eigenvalues is given here. That means I can say lambda 1 is equal to lambda 2. Lambda 1 is equal to lambda 2 because it is a 2 by 2 matrix here, right? The A is given, and where x is a real positive, x is a real positive value. So that means he's saying that being x is a real positive value. So how what is the value of it under the condition that the eigenvalues of this matrix are repeated and the matrix is given as a non-singular. Anyway, so how we are going to do that, let us see here. Generally, as it is a 2 by 2 matrix and saying that repeated eigenvalues, so how we can use that hint into this question, let's see that. Basically, if you generally the eigenvalues are given by the characteristic equation, correct? That is minus 1 whole square lambda square minus plus 1 minus 1 whole to the power of n, that is trace of A into lambda, and plus mod A is equal to 0 here, correct? So if you write that, so then this will be of lambda square, and the trace of A, what is trace of A? It is 4 plus x. So I can say it is minus of 4 plus x into lambda, and the mod A here, mod A is what exactly? So that is 4x plus 9, right? 4x plus 9 here, 4x plus 9, and that is equal to 0. So this is the way we are getting it. But now the clearly said that the repeated eigenvalues, that means lambda 1 is equal to lambda 2. My dear students, the characteristic equation is that repeated eigenvalues. So it's a quadratic equation is. So quadratic equation के लिए roots अगर equal होता है तो condition क्या होना चाहिए? So b square minus 4ac is equal to 0, correct? So we can use that here as a condition. So I can say that, my dear students, I can say here that since lambda 1 is equal to lambda 2, that means roots are equal. Roots are equal. So then b square minus 4ac must be is equal to 0 होना चाहिए. तो b square क्या होगा ये 4 plus x whole square minus 4 into a is 1 and this 4x plus 9 is equal to 0. And this is of 16 plus x square plus 8x minus 16x and minus 36 is equal to 0 here. And this equation we are simplifying it as minus 8x and this is a minus 20 is equal to 0. Dear students, please understand. Now here also, यहाँ पर भी x quadratic equation में आ गया. देखना, just find out the roots and in those roots which is the positive real number. But यहाँ तो clearly mention किया ना exam question में. So in the question it is very clearly given that x value is the real positive number. So therefore, if you solve this one na, if you solve this one, you are going to get so some 10 minus 2 करके आता है, right? So 10 minus 2. This is 8 and this is minus 20, right? 10 minus 2. So in this x, in these two values of x, which is a positive real number? So 10 is a positive real number. 10 is a positive real number. So the answer for this question should be 10. That is x is equal to 10 होना चाहिए. So this is the answer for this question. This is the answer for this question which is asked in the examination, right? But यहाँ पर तो general, you know, based on the roots formula, roots conditions यहाँ अगर यहाँ पर use किया है in the quadratic characteristic equation, so it is easy for us here, okay? But only thing is you must have a good practice, then only this kind of question can be solved, okay? If you have a good mathematical aptitude, then that algebra can be mixed into this solving this equation, and so that you can get the answers for this kind of questions, okay? Now I think many of the students have got the right answer. Yes. Okay. So this is the answer for this, right? So I think many of the students got the answer for this x is equal to 10 here, right? Yes. Yes, Rana, that is 10. So 10 is the right answer for this question. Okay. Yes, without any delay, we are moving on to the next question here, right? In this question here, it is a, okay, let me, okay, right, this question. Dear students, ये तो strange है कि यहाँ पर क्या हुआ है कि exactly question जो दिया है answers match नहीं कर रहे हैं. ये question जो दिया है इसके answers match नहीं कर रहे हैं as per this question. Either the question should have some data गलत हो सकता है, नहीं तो options में कुछ गलत हो सकते हैं, but somewhere some error is existing here, okay? But still, as the integral is given and the contour is given, according to the given integral and given answer, I mean given contour, I will do the answer for this. So I hope many of the students have got you know, confusion or some ambiguity in this question. Yes. Yes, Shubham. Yes. Yes, there is a confusion in this question. So definitely maybe MTA हो सकता है, क्योंकि अगर if the question is correct, if the question, I think you have seen the same question in the examination, if you seen the same function, same integral function and same contour, then definitely if the same options are given like this, then obviously it is going to be MAT. Obviously it is going to be MAT. MAT पे हो जाता है, right? Okay, right. MAT हो सकता है marks to all करके. But anyway, I'll solve this question as per the given data. Maybe varies, right? But I will give you the most solution for this. Dear students, here the poles are given by here z square into z square plus 4 is equal to 0. So from this we are getting z square is equal to 0, okay, and z plus 4 is equal to 0. If you solve this one, I can say z is equal to 0 is a pole of order 2. Pole of order m is equal to 2, okay, एंड अगर मैं इसको सॉल्व करता हूं तो आई विल बी गेटिंग दैट z इज इक्वल टू प्लस आर माइनस 2i, यही तो है. ओके, so these are the singularities we are getting for this one. So contour to दिया है, this is a circle here, this is a circle. So what is this circle exactly? You can see here the center of the circle. See this I is the center and 2 is the radius. I think everybody knows that, correct? Okay, you know this point. Okay, let us see that which poles and which singularities are inside this contour here, inside this contour, because we need to find out the residue only for the poles which are inside. देखते हैं, तो z is equal to 0 if you put it in the contour, that is mod z minus I is equal to 2. So you are getting that is 0 minus I is, I can say that yes, 0 minus I is getting 1 which is less than 2. So it is very clear, if you substitute any point in the circle equation and if you are getting the less than the radius, that means the point lies inside, right? So it lies inside the C here, okay. And there is another point, that is z is equal to 2i. अगर z is equal to 2i पे इसमें भी लगाते हैं, if you put it in the contour equation, so then you are going to get it is I which is 1 is less than 2 again, so again inside C, सही है, ठीक है. और जल्दी से जल्दी तीसरा भी ले लेंगे, तो ये क्या होगा, minus 2i minus I is getting mod 3i, mod minus 3i, which is absolutely greater than 2, तो मतलब ये है lies outside C here, है. So therefore we need to find out. And one more thing, this z is equal to 2i जो है, these are simple poles, right? And इसमें 2i जो है, ये है pole of order 2 है, और ये है simple pole, right? So now let us find out, ये simple pole है, let us find out the residue at both the points. So definitely I am taking some time for solving this question, so definitely the student will take some time to get this, because more than one pole inside, if I have to find out the residue at 0, that is 1 by 2 minus 1 factorial limit z tends to 0 d2 minus 1 by dz2 minus 1 of z minus 0 whole square sin z by z square plus 4 here. So this is what it is there. Now z square gets cancels and it is one time differentiation. If you put one time differentiation here, if the limit z tends to 0 and this differentiation is going to be u by v, so v u dash means cos z का sin z का differentiation है cos z minus v is u v dash divided by v square. So if you put the z tends to 0 here, this is 0 4 and cos 0 is 1, so 4 by, ये तो 0 है, so 4 by 4 square, that is 1 by 4 you are getting it is, right? You are getting it 1 by 4. I hope many of the students got this 1 by 4 at 0, right? The residue. फिर 2i पे करेंगे, so 2i पे is a singular pole, तो residue at 2i, that is limit z tends to 2i. So it is a simple pole na, so at simple pole you can say that is z minus 2i into sin z by z square into z minus 2i into z plus 2i, because I am writing z square plus 4 as like this. So z minus 2i gets cancels na. So now if I put 2i into this, na, so then I am getting here sin 2i, right? Sin 2i by यहाँ पर तो ये हो जाएगा 2i whole square. So 2i whole square is what? Minus 4 into 4i here, right? Into 4i. So this is what you are getting. So now, okay, anyway, I got the residues. Now I will go for CRT. Application of CRT is what? Yes, by CRT, by CRT, we can write by CRT, I can write integral C f of z dz is equal to 2 pi I into residue at 0 plus residue at 2i. So this is going to be 2 pi I into residue at 0. What is residue at 0 we are getting? At 0 तो हमको आया है कि 1/4 और रेसिड्यू at 2i आया कि sin 2i divided by minus 16i, right? Minus 16i. Okay, if I solve this one na, so this I'll be getting it is pi I by 4, okay, plus, and if you take this one, so I gets cancelled, pi sin 2i divided by 2, it gets cancelled, and this is, okay, I can write this one as a minus. So this is a minus here, pi sin 2i by 8 here. Dear students, अगर आप एक बार ऑप्शंस को देखते हैं, see देखिए, minus pi by 8 sin 2i is the only one term is there, but 1/4 is missing. See, options में तो 1/4 कहीं नहीं है, so pi by 4 तो बिल्कुल नहीं है. I hope everyone you got the same thing, right? Yes, minus 1/4 तो बिल्कुल नहीं है, so minus 1/4 नहीं है, तो therefore I can say there is no option in this one. But मेरा कहना एक है कि यह क्वेश्चन क्या हो सकता है. Actually there is some mistake we understand, but यहाँ से और क्या हो सकता है इसमें, तो according to me, suppose अगर ये क्वेश्चन में ये 0 है समझो, सॉरी ये 2 नहीं है समझो, only 1 है. If it is z into z square plus 4, so then the option D can be the answer. Then the option D can be the answer. तो ऐसा हो सकता है, but actually majority of the students, maximum students, the question is given as a z square only. So therefore, so according to that, I can say very clearly that options are not matching. So therefore, the marks can be given to all students. तो ये हो सकता है, right? Because the data is not perfect we have. So once we get the correct data, so we can conclude this. But anyway, so we are moving on to the next question here. Definitely, yes, consider the vector field. As you are the electronic students, so definitely the question takes place from the vector calculus, right? So यहाँ पर है ना, consider the vector field, this question, and in a rectangular coordinate system, f bar is irrotational. F bar is irrotational. So f bar is irrotational का समझ में आता है कि del cross f bar is equal to 0. So I, j, k, dou by dou x, dou by dou y, and dou by dou z. And f bar क्या होगा, 4y minus c1z and 4x plus 2z, और ये है 2y plus z है. So this del cross f bar must be 0 because the f bar is irrotational. If you solve this one na, so you will be getting that c1 is equal to 0. The constant c1 value जो आ रहा है वो 0 आया. Yes, Rana you got 0 and Jain you got 0. Very good. Krishna also got 0. Yes, yes. Arun Soni got 0 here. So very good. So many of the students have got. This question is easy only, right? This question is very easy and not expected for even the electronic students. Moving on to this next question, my dear students. This is a two continuous random variables of x and y are defined as y is equal to x plus 3. It's some linear expression is there. Okay, now he is asking about variance of y is what? What is variance of y in this? Okay, it's a very easy question, my dear. बहुत simple question है कि variance of y is nothing but variance of 2x plus 3. I say that variance of 2x plus 3. So this we can write it is of a variance of 2x plus variance of 3 here. But we know variance of ax can be written as 2 square variance of ax plus variance of any constant is 0. So therefore, so this one will be 4 variance of x here. Yes, which of the answer? Option B to sahi hai, right? Option B is getting the right answer. Yes, Arun Soni has given a right answer. Yes, many of the students, Vaibhav, Ranjit, yes, Jitendra. Okay, I think previous answer you are giving Jitendra, right? But anyway, so these are the questions here of the random variable. Now there is one from linear algebra side question. Dear students, ये तो पक्का हमारा एक CTQ कोर्स है CTQ course है उसमें से ये this same type of question I have taken here. This kind of representation I have given because many of the students, if the vectors are given in a different vector, I mean if the rows and columns are of the matrix are given in vector form, so definitely so they don't understand. Sometimes they will confuse how to go ahead. But ये इसमें ऐसा है, so we can understand very easily. What is the hint is given? Hint is that the linearly dependent. See, when do you say that a three set of vectors of 3-dimensional, so can be in linearly independent? Sorry, ये question में थोड़ा सा ये है. Linearly dependent, my dear students, please make a change of this. It's a linearly dependent है, then x is equal to what? So linearly dependent का मतलब है सीधा से सीधा mod a is equal to 0. Mod a is equal to 0. Okay, let me put the mod a here. That is 1. I am taking these vectors as a row vectors. 7 3 x and then it is 2 3 1, right? 2 3 1. So अगर ये जो है 0 होना चाहिए. Or now if you expand this is plus minus plus if you are fixing the first row, so then 1 into it is 3 minus 3x plus 1 into it is 7 minus 2x, then plus 2 into here 21 minus 6. So 21 minus 6 is absolutely 15 is equal to 0. So this is minus 3x minus 2x, it is minus 5x and ये तो 10 or 30 40 है. So minus 5x plus 40 is equal to 0. So x is equal to what? 8. So I think many of the students got 8. Yes, Balakrishna, right. I changed that. It is not independent, it is dependent, correct? Yes. Yes, dependent given. Very good, correct. I just by mistake it happened. Now 8 is the answer. 8 is the answer. Very good, very good. Many of the students have got the right answers. So I appreciate that you have got the answer. So there is one more question from vectors here. There is one more question from vectors. This f bar is given and integral c f bar dot dr bar is given, right? I hope, see what is the contour here? What is the contour is given of this line integral? We can understand work done also, right? Okay, so the theta is given. See, when theta is given and the radius is given as 1, so we have to find out this. So better you convert this one also in terms of r and theta, so that our integral will become easy for us. Okay, our integral will become easy for us. Let us see that how we are going to solve this. Integral c f bar dot dr bar means here it is integral minus xi plus yj into dot dxi plus dyj here, as it is a 2-dimensional. So we can write minus x dx plus y dy here along the contour here, c here, along the contour c. So you got 1 by 2. Let's check that 1 by 2 कैसे होता है. Anyway, so what I'll do is here, it is very clear that the radius is 1 here. So I want to take this x and y into polar coordinates. So in polar coordinates, that is x is equal to r cos theta, y is equal to r sin theta here, where theta varies from 0 to pi by 4. Because ये ही तो है contour. I forgot to mention this. So this is the contour, my dear students. ये कर्व के लिए theta varies from 0 to, actually this is the initial line that everybody knows, right? This is the initial line and this is the theta equal to 45 in polar coordinate system. तो ये है r varies from 0 to 1, theta varies from 0 to 45, right? तो ये है. So sorry, radius is fixed, that is r is equal to 1. Radius vector is moving from 0 to 45 here. तो ये है. So then now if I will be converting this as the radius is 1, so r is equal to 1 के लिए, so x is equal to cos theta, y is equal to sin theta होगा. So therefore this will become theta varies from 0 to pi by 4 and this is sin theta, sorry, cos theta. What is the dx becomes minus sin theta d theta and plus sin theta into cos theta d theta here. D theta here. So this is going to be 0 to pi by 4, 0 to pi by 4 and this is going to be, yes, It is sin theta cos theta, sin theta cos theta, 2 sin theta cos theta, that is sin 2 theta. So this becomes sin 2 theta d theta. The integration will give you minus cos 2 theta by 2 from 0 to pi by 4. And this answer is going to be what? Yes. So this answer is going to be minus 1 by 2 if you keep outside. So this is cos pi by 4. So pi by 2, cos pi by 2 is 0 minus and cos 0. Cos 0 is 1 by 2. So this answer is coming out 1 by 4. The answer is coming out 1 by 4. So this is the answer for this question of the line integral here, because as the theta is mentioned and the figure is mentioned in terms of the polar coordinates and the functional integral function is given in the Cartesian coordinates. So better you take them into the either this or that, better to convert into the polar coordinates so that the integral will become easy for us. Okay. Yes. So this is, with this I am concluding this session because I have already solved all the questions. So there might be some more questions, but here as per the data which we are getting as a prominent data, so based on that we have done these questions here, and I hope everyone has done very well in the examination. So next my colleague will take the session here. Okay, thank you.
Hello everyone, I'm Aditya Kamal and I'll be dealing with the control system part that appeared in the GATE exam today. So on the based on the memory, whatever data we have collected, I'm going to solve those questions. And as I told in the network case also, we have collected it. It's a memory based actually questions. These are the memory based questions that we have. So the perfect question or the, if there is any discrepancy in the data is because the memory, recollection from the memory can be wrong. So the perfect questions will be solved or the things will be rectified when the GATE will give the proper question paper. So let's see this question. In this question, we were supposed to find y of s upon x of s. This was the question actually. So see, this was a very easy question. If you have solved it with the block diagram also, it's okay, but you could have easily solved it with the help of the Mason-Gain formula. As I told in the class also, that you can easily see the forward paths, you can easily see the loops. So why to draw the signal flow graph also? What normally students do, they draw the signal flow graph also. Do not draw the signal flow graph also, because this is the signal flow graph. Just try to imagine signal flow graph. Nodes, path gains. So why to draw it? It's a small one. So if you see the transfer function y of s upon x of s, let's see what we have. How many forward paths? From input 1, and another forward path 2. So we'll be having P1 delta 1 plus P2 delta 2 divided by delta. Now how many loops we have? I can notice one loop. Can you observe some other loop? No. If you go from here, there is no path to return. So we have only one loop, and both the forward paths are having a node common that they are touching the loop. So delta 1 and delta 2 is going to be 1. So P1 is G1, delta 1 is 1, plus P2 is G2, delta 2 is 1, divided by delta is 1 minus sum of all loops, only one loop we have, that is G1 H1 minus 1, so minus minus plus G1 H1. So this is a transfer function for this question. So that's it, it was an easy question. Moving to the next question. In this question they have given GSHS has 1 0 in the right half side. Okay, the open loop transfer function has 1 0 in the right half side. Let's use that information. I'm talking about the open loop transfer function over here. Okay, so what is the formula that we have for absolute stability from the Nyquist? N is equal to P plus minus Z plus. Okay, now N is the number of encirclement of the origin in case of open loop transfer function. Fine, let's see what the information that we have. How many encirclements of the origin? 0. Okay. P plus. Have they given any information regarding the number of poles of the open loop transfer function in the right half? No. Okay. Unknown. P plus. Minus Z plus. Number of zeros of the open loop transfer function in the right half. Have they given any information? Yes. 1 0 in right half side of GSHS. Okay. So Z plus is 1. So you can see P plus is coming equal to 1. That is, one pole of the open loop transfer function will be lying in the right half side. Okay, that's the information that we have. Now, he is talking about the poles of the closed loop transfer function which are in the right half side plane. Okay, so again the same thing. We are talking about the closed loop transfer function. The formula is going to be N is equal to P plus minus Z plus. Now, what is P plus over here? If you notice in this case, the N plus is the encirclement of the minus 1 comma J0 point. P plus are the poles of the closed loop transfer function, P plus are the poles of the characteristic equation in the right half side. And you know that the poles of the characteristic equation are same as the poles of the open loop transfer function. Okay, so P plus we have 1. What is Z plus? Z plus are the zeros of the characteristic equation which are in the right half side, and we know that the zeros of the characteristic equation are same as the poles of the closed loop transfer function, and this is what we are interested in calculating. Okay, so let's solve it. And number of encirclements of the minus 1 comma J0 point. Okay, one encirclement in the counterclockwise direction, so plus 1. Then another encirclement of the minus 1 comma J0 point in the clockwise direction, that is minus 1. Therefore, N will be minus 1 plus 1, that is 0. P plus 1 minus Z plus. From here we can see Z plus is coming equal to 1, that is 1 0 of the characteristic equation will be lying in the right half side of the S plane, that is of the G of G omega, and that is G of G omega H of G omega plane, that is one pole of the closed loop transfer function will be lying in the right half side. Therefore, the answer will be 1. So that's all. That's a question I was able to collect on the control system part. So rest of the portion of other subjects will be taken by my colleagues, so they will be joining you very soon.
Dear students, this is Naresh Reddy. Based on the inputs received from the students, now I'm going to solve the questions from the subject communication systems. If you see this question is based on phase modulation. The similar model of question I done in the recent GTQ course. Okay. And here a sinusoidal message signal having RMS value of 4 volts with frequency of 1 kHz given to phase modulator with Kp is equals to 2 radians per volt. The carrier signal is given by 2 cos 2 pi into 10 power 16. Find maximum instantaneous frequency in hertz we have to find out. So here for sinusoidal signal V peak is equals to root 2 V RMS. Yes, for sinusoidal message signal, VRMS equals to V peak by root 2. So V peak is equals to root 2 VRMS. and VRMS is given 4. So it is 4 root 2 volts. This is the peak voltage of the given sinusoidal message signal. And what is the frequency given here? 1 kilohertz. So the message signal, okay, is going to be like this. The peak voltage is 4 root 2. Sinusoidal signal means you can take either sine or cos, that's your wish. Okay, so I'm taking sine here. Sine 2 pi. Frequency is how much? 1 kilohertz. So this is 10 power 3 t. So indirectly, this is the message signal given to us. Yes, students, you can take sine or cos here. You will get the same result here. The answer is going to be same here. Okay. Now, Kp is given 2 radians per volt. That's okay. And this is the carrier signal given. And we have to find maximum instantaneous frequency, okay, for the given phase modulator. We have to find out for the resultant PM signal. We have to find maximum instantaneous frequency. So Fi is equals to the instantaneous frequency, okay, of the resultant PM signal is Fc plus Kp by 2 pi differentiation of Mt. It is the instantaneous frequency of the resultant PM signal. And we have to find maximum instantaneous frequency. Fc remains unchanged. And for the given phase modulator, Kp remains unchanged. So to find Fi max, we have to take maximum positive peak possible for differentiation of Mt. So it is differentiation of Mt maximum. If differentiation of Mt is taking maximum positive value, maximum positive peak, this Fi becomes Fi max. So we have to find what is the maximum positive value possible for differentiation of Mt. We have to find out. So this is Mt given. So if you try to find differentiation of Mt, what is the differentiation of Mt? So differentiation of sine will be cos, and this 2 pi into 10 power 3 comes outside. So 2 pi into 10 power 3. Okay, and 4 root 2 of course there, and differentiation of sine will be cos. So this is cos 2 pi into 10 power 3t. It is differentiation of Mt. And what is the maximum positive value possible for differentiation of Mt? So what is the maximum positive peak of this? This is the maximum positive peak. If you take Vm cos, the signal in the form of Vm cos, the maximum positive value possible for that signal is Vm. So that is 2 pi into 10 power 3 into 4 root 2 volts. This is, it is a maximum positive value possible for differentiation of Mt. And if you substitute here, okay, and one thing, we have to find maximum instantaneous frequency in hertz. We have to find out. You have to take care of these units here. Fc is okay, what is the carrier frequency? 1 megahertz, 1000 kilohertz. So this is, so 1000 into 10 power 3 hertz. Okay, so we have to find in hertz. So that is 1000 kilohertz, 1000 into 10 power 3 hertz plus Kp by 2 pi. Kp is given how much? 2 by 2 pi. This is okay. And what is the maximum positive value possible for this? That is 2 pi into 10 power 3 into 4 root 2. This is, so this is okay. And if you try to find the value for this, so what this will be, this is 1000 into 10 power 3 hertz plus, and here 2 pi will be cancelled. So this is 4 2s are 8. This is 8 root 2 into 10 power 3. Okay, yes, this 2 pi will be cancelled. So this is 8 root 2 into 10 power 3. So this comes to be, so what is this value will be? 1011313.7 hertz. Okay, so this is going to be answer here. Okay, so 1011313. This is the maximum instantaneous frequency in hertz. Okay, now if you see the next question, this question is about finding Nyquist rate. This question is based on the sampling theorem. Fine. So a baseband signal, band limited to 10 kilohertz. So a signal xt, okay, here a signal xt is band limited to 10 kilohertz. Then we have to find the Nyquist rate for this signal xt into xt by 2 plus 1.
Okay, so here if you see the spectrum of xt, xf, it is band limited to 10 kilohertz. So it is 10 kilohertz and minus 10 kilohertz. Fine. Now we have to find Nyquist rate of this yt. So for this, first we have to get the spectrum of this yt. Okay, so what is the spectrum of yt is? Okay, the spectrum, this double arrow mark specifies spectrum here. Okay, will be time domain multiplication, frequency domain convolution. Okay, xt, what is the spectrum of xt? It is given like this, minus 10 kilohertz and 10 kilohertz convolution width. Yes, time domain multiplication, frequency domain convolution. Then what is the spectrum of x of t by 2 plus 1? Okay, so x of t by 2 means x of t is expanded by a factor of 2. Okay, so time domain expansion results in frequency domain compression. So frequency domain compression, so it is compressed by a factor of 2. So if it is compressed by a factor of 2, the spectrum is going to be like this. So this is minus 5 kilohertz and 5 kilohertz. This is, yes, time domain expansion results in frequency domain compression. So it is xt is expanded by a factor of 2. So this xf is compressed by a factor of 2. So the spectrum will be from minus 5 kilohertz to 5 kilohertz. And one thing, this plus 1 what you see, okay, is not having any effect on the frequency band. Okay, so the time shifting will not affect the frequency band of the signal. The frequency band will remain same like this only. So that is minus 5 kilohertz to 5 kilohertz. So the frequency band of x of t by 2 and frequency band of x of t by 2 plus 1 is going to be same. The frequency band is going to be same. Okay, fine. So it will be, so if you perform convolution operation, so we are not interested in the shape of the spectrum, we are interested in the frequency band only to find the Nyquist rate. Okay, so you will get some curve based spectrum you are going to get here. And one thing, in the process of convolution, the lower limit will be equals to sum of the lower limits, minus 15 kilohertz. Upper limit will be sum of the upper limits. This is 15 kilohertz. Okay, so it is the spectrum of yt. Okay, and we have to find Nyquist rate of yt. Nyquist rate is nothing but 2 into f max. 2 into highest frequency will give you Nyquist rate. So 2 into, what is the highest frequency of yt here? 15 kilohertz. So 2 into 15 kilohertz. So this will be 30 kilohertz. So Nyquist rate is here 30 kilohertz. So which option here is correct is option A will be correct here. And if you see the next question, so this is a simple question. It is about finding image frequency of super heterodyne receiver. Here a receiver is tuned to 600 kilohertz. So fs is given as 600 kilohertz and the local oscillator frequency is given by 1000 kilohertz. So FL is given as 1000 kilohertz and we have to find image frequency, we have to find out in kilohertz, we have to find out. Okay, and one thing in this question, relation between FL and FS is not given. Is FL greater than FS or FL less than FS is not given. So the default will be FL greater than FS. Okay, and with FL greater than FS, the intermediate frequency IF is equals to FL minus FS. Okay, so let's find out this IF first. FL minus FS, so 1000 kilohertz minus 600 kilohertz, so that will be 400 kilohertz. IF we got, and with FL greater than FS, the image frequency will be FS plus 2IF. Okay, so FS plus 2IF means this is 600 kilohertz plus 2IF will be 800 kilohertz. So it comes to be 1400 kilohertz. So the image frequency in kilohertz will be 1400 will be the answer here. And if you see the next question, this is about random variables. Here two random variables x and y related like this, y is equals to 2x plus 3. Then we have to relate the variance of x with variance of y. Okay, so this is very simple question. Okay, you can directly put the answer here. That is, variance of y will be equals to 4 times to the variance of x. Okay, so the answer will be here. So B will be the answer here. Even if you see this here, the variance of y is equals to, the basic formula will be expectation of y minus y bar square. It is a basic formula to find the variance of a random variable, where y bar is nothing but expectation of y. So if you see the expectation of y, that is y bar is equals to, so y is equals to 2x plus 3, and expectation of y is equals to 2 into expectation of x here, plus expectation of 3 will be 3 only. Expectation of constant is same constant. So here y bar is equals to 2 into x bar plus 3. Okay, now variance of y is equals to expectation of y minus y bar square. Y is equals to how much given? 2x plus 3. Okay, this is y. Minus y is 2x plus 3 minus y bar. Y bar is what here? Minus y bar. So 2x bar minus 3, this is. Okay, so y minus y bar. Minus y bar means minus 2x bar minus 3. So this is square. Okay, y minus y bar square. So here 3 will be cancelled here. So this is expectation of, this is 2x minus 2x bar square, this is. Okay, so this is expectation of 4 into x minus x bar square. Okay, so expectation of kx, you can write k into expectation of x, you can write. So you can write 4 outside here. So this is 4 into expectation of x minus x bar square. Okay, so it will be 4 into expectation of x minus x bar square is nothing but that is variance of x only. That is a basic formula to find variance. Variance of x is expectation of x minus x bar square. So variance of y is equals to 4 times to variance of x. So 4 times to variance of x. Option B is correct here. And if you see the next question, it is also a simple question. So for a WSS random process xt, the autocorrelation function is given here. And we have to find the average power of xt here. Okay, so for a random process, the average power is nothing but total power only, you have to understand. Okay, yes, I said this multiple times in communication system subject. So wherever the question is about finding average power, you have to find that, you have to understand that as total power only. Okay, so this is this average power is equals to, for WSS random process, okay, ACF Rx tau at tau is equal 0 will give you the power of that random process only. So this is mean square value of xt. Okay, I said average power is nothing but total power only. Okay, so for a random process, the mean square value will give its power. The mean square value of xt, that is expectation of x square t. You can understand this as expectation of x square t also. The power of xt is nothing but expectation of x square t will give the power of xt, and that will be equals to Rx of 0. Yes, for WSS random process, Rx tau at tau is equal 0 will give its power. So Rx is 0. So what is Rx tau at tau is equal 0? This is 2. Okay, so what is the height here? You have to say Rx tau at tau is equal 0. So this will be 2 watts. This will be. So what is the answer here will be 2. It's simple question. Okay, so Rx tau at tau is equal 0 will give its power. The only thing you have to understand here is the average power is nothing but here the total power only. The total power of this random process for WSS random process will be equals to Rx of 0. Okay, so this height will be the answer simply. Okay, so according to the given data, so 2 will be the answer. And if you see this question, this is also a simple question, okay, directly from the classroom. Okay, of course all the questions we discussed here, okay, these are from classroom notes only directly. Very simple questions from communication systems. Yes. So here, this is about amplitude modulation. So a carrier is amplitude modulated with 50% of modulation. Okay. So mu is given as 0.5. Percentage of modulation is nothing but modulation index. So mu is given 0.5. Okay. Find percentage of power saved if carrier and one of the sideband is removed. So here from the given AM, okay, the carrier and one of the sideband is removed. Then what is the percentage of power saved? We have to find out. Okay, so from the given AM, if carrier and one of the sideband is removed, the resultant modulated signal is SSB. So this question is simply about what is the percentage of power saved in the resultant SSB modulated signal compared to the given AM signal. So this is simply formula based question. So percentage of power saved. I already given the formula in classroom lectures, that is 4 plus mu square by 4 plus 2 mu square. Okay, so percentage of power saved in the resultant SSB compared to given AM. So this is the formula, 4 plus mu square by 4 plus 2 mu square. So mu value is given. If you substitute mu value here, so you come to know this is 94.4%. Okay, so 94.4 will be the answer. Just substitute mu value here 0.5 and this is the answer you are going to get. Okay, and this question is from delta modulation. This is also a direct question, a simple question here. Here, a sinusoidal signal having frequency 4 kilohertz with peak voltage of 4 volts is given to delta modulator. Fine. The signal is sampled at the rate of 32 kilohertz. What is the value of minimum step size required to avoid slope overload error? Okay. And if the message signal is sinusoidal message signal, then to avoid SOE, slope overload error, what is the condition to be satisfied is delta by TS should be greater than or equals to 2 pi FM AM. So if the message signal is sinusoidal message signal, then this is the condition to be satisfied to avoid SOE, slope overload error. So this is delta. 1 by TS is nothing but Fs. So what is the sampling rate given? That is 32 kilohertz is given. Should be greater than or equals to 2 pi, okay, FM. What is the message frequency? 4 kilohertz given here. Okay, and AM. And amplitude is given as 4 volts. Okay. Now this delta we have to find out. Delta greater than or equals to, this is 4 just 16 to the 32. 32 pi. This is K. So this is kilohertz is there na K by 32 kilohertz. Okay. So this 32 kilohertz comes this side. So this will be 4 just 16 to 32 pi by 32 kilohertz. So kilohertz will be cancelled. So delta greater than or equals to pi volts. Okay, so the volts is there. Okay, so then delta minimum. What is the minimum step size required to maintain is pi volts. Okay, so this is pi means 3.14. Okay. So what is the minimum step size required to avoid SOE is, that is 3.14 volts. Okay. So these are the questions from communication systems. And this the inputs about these questions I received from students. And I came to know that one question is given from linear block code also. But the exact data the students were unable to produced. Okay, they are unable to give the complete data about that question. But I came to know that that question is about finding the valid code word. Okay, for a linear block code in LBC, for a valid code word C, so C into H transpose should be equal 0. So based on that, you can solve that question. So that is going to be definitely easy question only. Okay. And so these questions I feel like very easy questions given from communication systems. So I hope you done these questions. Okay, thank you, students.
Hello students, welcome to this session of GATE 2021 Electronics. In that EDC questions, further the solutions. Here in the case of EDC, based on the students memory based, the questions that we are having here is up to now is, you can see the question on the screen. Here the question they asked is, there is a p-type semiconductor given. So given is a p-type semiconductor with non-uniform doping, they mentioned the question. And here the energy levels, if you see here, this is the energy level EV, which is bending with slope, it is present, and this is, they mentioned here, Fermi level EF, which is not having any change there. So this is the thing they are having like that. And the value of electric field, in this case what it is they are asking, and for that one options are given like this, some ABCD options like this. Here if you observe one interesting thing, here this is given here as L, and this EV is having the energy of delta. So based on this data, this question has to be solved. Dear students, in order to solve this one, this is actually speaking, the question is having so much of depth in the concept. As we discussed, the horizontal expansion of the subject is very important here to get this vertical expansion point. And in this particular case, the points actually, what the conceptual point here required is, you know one thing, when electric field is present, then the electric field and energy levels, for that what is the relation we have to extract, based on that we should have the discussion. So for that, let me give some idea about this particular question, what is the approach we should make it to solve this one. Yeah, for that one, let me consider one situation here. As you know, the energy level of an electron is nothing but the possible potential energy level of electron with respect to the nucleus. So based on that we are defining the energy level. And if you consider here an energy level, let me consider, this is suppose an energy level we are saying here, this is the energy level. So this is some energy level EC, and this is the energy level EV, we can say for example. In this particular case here, this energy value, for that one, the energy of electron, if electron is present here, the energy of electron is given as minus E into V, we can say. So this is a relation that we are having between the energy and the potential. So for that one, of course, we can also mention this is minus QV, this is nothing but the energy E. So from that we can say the potential V is nothing but minus here E by Q, or simply that is only we are writing minus 1 by Q into E is nothing but the potential. So this is a very important relation that we are going to use here to solve that particular problem. Here, as far as these energy levels are concerned, the bending of energy levels, why it is taking place, is going to play a very important role to solve this question. The bending of energy levels, for that the reason is the electric field. When electric field is present, that may be the externally applied electric field or built-in electric field. Because of that, we can get the bending in the energy levels. Sir, you may ask a question like this, sir, but what is the relation between that, the energy of electron and the potential present there? For these things, what is the relation? You may ask a question like that. So in order to have the, in order to give the clarity about it, let me have the point of discussion here. That is, as you know, we are having a relation E is equal to minus dV of x by dx, isn't it? Here we are going to consider here E is nothing but, we are saying that is nothing but E of x. The electric field variation is equal to the dV of x by dx, we are writing with minus. This is the thing we are already having a relation. Now in this particular one, if you put this minus 1 by Q into E, where this E is nothing but, this is nothing but what we are saying, energy, isn't it? So that one, if you are going to keep here the relation, in this relation we are going to get minus d by dx of that one we are going to say as minus 1 by q into E. So based on that, simply we are going to get 1 by q into dE by dx. So this is nothing but electric field variation is going to depend on the differentiation of this particular energy with respect to the x. That means in these energy levels, if they are having any variation, the variation of energy levels is going to give the electric field is the meaning of this particular expression. So whenever there is an variation in the energy level, that means the electric field should be present there, that we are going to get the information from this particular equation. And this one we got simply like this, no, the energy value of electron, from that we got the potential and the energy, for that the relation we got here. And based on that relation, when we are keeping that relation in this particular expression, which is already we know very well, in that then we got this particular relation finally. This relation, what is the information that it is giving is important for us, and that information is nothing but, I said no, this is nothing but, if energy is having any variation in the energy levels, then we can have the electric field there. That means whenever we can say also like this, whenever electric field is present, there should be the variation in the energy levels, like that. That may be of EC, or that may be of EV, or that may be of intrinsic energy level, whatever it may be, this energy level. Because basically energy level, that may be of N type or P type, or in those the valence level or conduction level or the intrinsic energy level, these are going to have the effect by the electric field. That is the point that we are getting from this. So let me have that point only, let me write that equation here. That means from this we can write E of x is equal to, we can also say this one as like this, 1 by q into, we can say dE, that means dEc by dx, we can write if in the view of this conduction energy level. Okay, otherwise we can also say that E of x is equal to 1 by q into dEv by dx also we can say. And in the same manner we can also say for the intrinsic energy level also like this, that is E of x is equal to 1 by q into dEi by dx, like that. So these are the three important relations that based on which we are, these all the things we are writing, these are three relations also nothing but from this basic relation only we are applying that relation, whether it may be of conduction level or valence level or intrinsic level. That is the thing. These students here, the important basic funda here is the basic point, the funda here is what it is now. Here whenever, I am repeating that point, whenever there is a variation in the energy level, that means the energy, then that is going to establish the electric field. And you may ask a question here to me, sir, if electric field, if it is, if the energy is 0, then what may happen, sir, here? Yeah, that means dE by energy variation it is 0, say like this, dE by dx if it is 0, then what we can say? So that means E is equal to what? The meaning is nothing but constant, isn't it? That means dE by dx, the variation in the energy if it is 0, that means if the energy is constant, that means this entire thing is going to become as 0 only, no? That means electric field is also going to be 0 only, no? That means whenever there is a variation in the energy, then only electric field is present. If variation in the energy is 0, that means there is no variation, that means these energy levels are, say for example, like this only present without bending like this or like that. If they are present straight like this only, in that case, that means when there is no bending at all, in that case we can say there is no variation. No variation in the sense the energy is constant, that means dE by dx is 0, means when dE by dx it is 0 means electric field is also going to become as 0. So that is the relation between the energy and the electric field. That electric field may be the built-in electric field or it may be the applied electric field, like that. Got it? So these points only in a simple in the Hindi also I'm going to explain these 2 points little bit for the benefit of all the students. स्टूडेंट्स यहाँ हमको इम्पोर्टेंटली एक बात को बिल्कुल अच्छी तरह ऐसे समझना है कि जब हमको एनर्जी लेवल में बेंडिंग जो कुछ मिलता है, इसका मतलब वो एनर्जी लेवल का बेंडिंग से हमको पता चलता है कि एनर्जी का वेरिएशन है. जब एनर्जी का वेरिएशन है तो इससे हमको मिलता है इलेक्ट्रिक फील्ड. सो इलेक्ट्रिक फील्ड एंड एनर्जी लेवल का वेरिएशन का रिलेशन ये है. अगर एनर्जी लेवल का कोई वेरिएशन नहीं, वो सीधा ऐसा रहा एनर्जी लेवल्स, चाहे वो कंडक्शन लेवल हो या चाहे वो वैलेंस लेवल हो या इंट्रिंसिक लेवल हो, अगर दीज लेवल्स में कोई भी हमको बेंडिंग कुछ भी नहीं है तो सीधा ऐसा रहा, स्ट्राइट में ऐसा रहा, तो इसका मतलब हम क्या बोलेंगे, एनर्जी तो कुछ भी वेरिएशन नहीं. ऐसा सीधा रहा तो एनर्जी का वेरिएशन कुछ भी नहीं, इसका मतलब एनर्जी इज कांस्टेंट, वेरिएशन तो जीरो. तो अब इस पर्टिकुलर इक्वेशन में आप एनर्जी को जीरो सब्स्टिट्यूट करने से इलेक्ट्रिक फील्ड भी हमको जीरो मिलेगा. मतलब अगर पिक्चर ऐसा है तो इससे हमको क्या पता चलता है, डेफिनेटली दैट वी आर गोइंग टू गेट. इससे हमको पता चलने वाला बात क्या है कि सीधा है एनर्जी लेवल्स, मतलब एनर्जी लेवल्स में कोई वेरिएशन नहीं. इसका मतलब वेरिएशन नहीं मतलब इलेक्ट्रिक फील्ड भी इस केस में नहीं, ऐसा हम बोल सकते हैं. ओके, दिस इज द पर्टिकुलर थिंग वी आर गोइंग टू हैव, चाहे वो AC हो या AV हो. अदरवाइज इफ यू आर हैविंग दिस पर्टिकुलर इंट्रिंसिक का भी कोई इंट्रिंसिक का भी लेवल हो, अगर ये सीधा लेवल्स हैं तो हमको मिलने वाला बात ये है. ओके, दिस इज एन एग्जाम्पल डिस्कशन आई एम जस्ट टेकिंग बाई दिस पर्टिकुलर सेमीकंडक्टर, है ना. अब हम इसी को लेकर जब हम इलेक्ट्रिक फील्ड अप्लाई किया तो क्या होगा वो बात हम देखेंगे. ओके, अगर इलेक्ट्रिक फील्ड इसमें अप्लाई किया तो होने वाला बात क्या है कि लेट मी से दैट पॉइंट हियर. फॉर दैट वन, इफ यू कंसिडर, इफ यू आप ऐसा एक एनर्जी लेवल लीजिए, दिस इज AC, दिस इज AV. ओके, एंड अगर इफ इट इज दिस आर द एनर्जी लेवल्स, इंट्रिंसिक लेवल में लिया तो इंट्रिंसिक लेवल है तो हम EFI यहाँ बोलेंगे, है ना. लेकिन अगर ये P टाइप सेमीकंडक्टर है तो P टाइप सेमीकंडक्टर में हम क्या लिखेंगे, द फेर्मी लेवल इज गोइंग टू बी नियर टू द EV, लाइक दिस वी आर गोइंग टू राइट दिस इज द फेर्मी लेवल इन द P टाइप if it is P type semiconductor. So in this case what we can say, अगर पिक्चर ऐसा है तो यहाँ का दूरी हमेशा हर एक जगह सेम रहा, इसका मतलब इट इज यू कैन से एज यूनिफॉर्म डोपिंग. यूनिफॉर्म डोपिंग, ओके, P टाइप एंड यूनिफॉर्म डोपिंग. ओके, और इस पर्टिकुलर केस में हम यानी इलेक्ट्रिक फील्ड कितना है अगर पूछा तो व्हाट इज द इलेक्ट्रिक फील्ड पूछा तो आप बोलिए इससे इलेक्ट्रिक फील्ड कितना मिलता है. अभी हम ये रिलेशन सीखा था, अब हम उसको यहाँ अप्लाई करेंगे. इलेक्ट्रिक फील्ड E ऑफ x इज नथिंग बट 1/q इंटू कोई भी फार्मूला इससे हम ले सकते हैं, क्योंकि ये तीनों फार्मूले हमको इसी फार्मूले से ही मिला है ना स्टूडेंट्स. सो 1/q इंटू DE/dx ऐसा है ना. इसमें हम अब AC हो या AV हो या I इंट्रिंसिक लेवल हो, कुछ भी हम ले सकते हैं. फेर्मी लेवल के बारे में मत लेना, वहाँ वी आर टॉकिंग अबाउट AC और AV और EA. और ये वाला एनर्जी लेवल्स में अब हम बात किया तो इसमें दीज आर स्ट्राइट, सीधा रहा है, मतलब हम क्या बोलेंगे, DEC/dx इज जीरो, अदरवाइज DEC/dx, DV/dx एंड DEI/dx इंट्रिंसिक का ये भी जीरो है. मतलब इन दिस पर्टिकुलर केस वी आर गोइंग टू कीप हियर दिस इज नथिंग बट जीरो. सो दैट इज गोइंग टू गिव द आंसर इज नथिंग बट इलेक्ट्रिक फील्ड वी आर गोइंग टू गेट द जीरो ओनली इन दिस पर्टिकुलर केस. समझ में आए ना. ये तो यूनिफॉर्म डोपिंग है. एक ही बात है, वहाँ याद रखने का बात ये है कि सीधा है एनर्जी लेवल्स, मतलब एनर्जी में कोई वेरिएशन नहीं. सो एनर्जी में कोई वेरिएशन नहीं तो ये वाला बिकम्स जीरो. इससे हमको पता चलता है वहाँ इलेक्ट्रिक फील्ड एस्टॉब्लिश्ड नहीं है, चाहे वो बिल्ट इन इंटरनल इलेक्ट्रिक फील्ड हो या एक्सटर्नली अप्लाइड इलेक्ट्रिक फील्ड हो, दोनों कुछ भी वहाँ नहीं है. समझ में आ रहा है ना. अब हम ये देखेंगे, इसमें हम अब पी टाइप सेमीकंडक्टर नॉन यूनिफॉर्म डोपिंग का केस दिया था ना प्रॉब्लम में देखिए ये तो नॉन यूनिफॉर्म डोपिंग दिया और ये पी टाइप दिया है ना दिया। तो अब हमको इस पर्टिकुलर केस में क्या बोला था, दिस थिंग दे सेड एज L एंड दिस पर्टिकुलर एनर्जी वैल्यू दे सेड एज डेल्टा। अब हमको फार्मूला क्या मिला था वहां, यहाँ फार्मूला क्या है देखिए, E of x इक्वल टू 1/q इंटू dE/dx है ना, चाहे दैट इज EC और EV उनको हम अप्लाई कर सकते हैं। तो इसको लेकर हम यहाँ लिखिए तो E of x इलेक्ट्रिक फील्ड इज नथिंग बट 1/q इंटू dE/dx है ना, चाहे that is EV also we can write it. Now here values are already given. No, here this is nothing but what is that, the value is nothing but delta and this is nothing but they gave as L, isn't it? So in the place of dV/dx we are going to write this particular thing. So अब हम इससे क्या मिलेगा, electric field is nothing but 1/q into delta by L. So this is nothing but this option only. No, we got it. This is only the option, no, delta by QL, that is only, no, we got it here. समझ में आया ना? It is so simple if you know the conceptual clarity. Students, please remember one important point here. Whenever energy levels are straight without bending, there is no electric field, because we got the relation between the electric field and the energy is like we are having electric field is nothing but 1/q into dE/dx. तो एनर्जी लेवल से सीधा रहा, कोई बेंडिंग उसमें नहीं, तो वेरिएशन ऑफ एनर्जी नहीं, तो वहाँ इलेक्ट्रिक फील्ड नहीं है। समझ में आए ना? लेकिन अब इस पिक्चर को देख के आपको डाउट आएगा कि सर ये ऐसा बेंडिंग क्यों था, EF तो सीधा था, ये तो EF है। ओके, दिस इज एक्चुअली EF फेर्मी लेवल इन द पी टाइप। और सर ऐसा बेंडिंग क्यों है, ऐसा बेंडिंग क्यों है कि बिकॉज इट इज नॉन यूनिफॉर्म डोपिंग। नो, फेर्मी लेवल बहुत नजदीक है EV के प्लेस में, लेकिन यहाँ दूर है। दैट मीन्स इट इज द इंडिकेशन दैट हियर heavy doping in this place, heavy doping, and here we can say as light doping. Okay, because of that we got here more gap and here it is less gap. Now this particular question was simply solved based on this expression. Okay, लेकिन आपको एक डाउट ये आएगा कि सर यहाँ पी टाइप सेमीकंडक्टर तो ऐसा ही रहा है, यहाँ बाहर से कोई भी इलेक्ट्रिक फील्ड या वोल्टेज अप्लाइड नहीं, तो इस पर्टिकुलर केस में हमको ये वाला ऐसा पोटेंशियल एस्टैब्लिशमेंट कैसा हुआ सर? इसमें हमको पोटेंशियल वेरिएशन के कारण ही है ना सर, इलेक्ट्रिक फील्ड भी एस्टैब्लिश्ड है, तो वहाँ पोटेंशियल का वेरिएशन कैसा हुआ है, ऐसा डाउट आपको आ सकता है। इसलिए मैं इस पर्टिकुलर पॉइंट को थोड़ा सा एक्सप्लेन करूंगा। यहाँ देखिए, इसमें हमको in this particular case if you observe one interesting thing here, in the case of that p type semiconductor जो हम ले रहे हैं, this p type semiconductor में एक p type semiconductor था। ओके, इसका पिक्चर what they mentioned, they tell me here, they give like this the picture, that means here they said this is nothing but EV they mentioned, and of course this is nothing but the EF they mentioned. Okay, है ना, this is picture only, no, that picture only we just made here. Of course this is we are having L and this is they mentioned as delta del. Okay, and just you focus on these two things children here. This is p type semiconductor. Then potential establishment, how we got it, I am going to say. As you know, p type semiconductor is having the negative ions and holes. So based on that, if you are going to make the picture here doping is more, isn't it? Here doping ज़्यादा है, so negative ions here more है, negative ions here more, negative ions here less. Like that, if you see the picture here, negative ions, like this. Sir, only negative ions, why you are mentioning, sir? Of course I am going to write the holes also, no, there. So negative ions and holes like this we are having. Okay, in this particular picture if you observe, here negative ions only, you just focus on them. Negative ions here are more negative ions, okay, so it is negative, so it is going to be treated as positive in comparison. That means here it is negative potential and here it is positive potential. Sir, where is positive potential? Sir, both are, all are negative ions only, no? Like that you may ask a question to me. In comparison, relatively, this end is based on the negative ions which are immobile. Based on that, we are going to define the built-in electric field. Here it is more negative ions, that's why this end is becoming as negative, and this end is nothing but, this particular end is, let me mention the names here, A and B, okay, to avoid the confusion. स्टूडेंट्स, यहाँ हम B एंड पे मोर नेगेटिव आयंस था और A एंड पे लेस नेगेटिव आयंस हैं, मतलब मोर नेगेटिव आयंस को हम नेगेटिव बोलते हुए, यहाँ A एंड पे लेस नेगेटिव आयंस को पॉजिटिव पोटेंशियल बोलते हुए, ऐसा हमको पॉजिटिव नेगेटिव ऐसा पोटेंशियल का वेरिएशन है. सो पोटेंशियल यहाँ पॉजिटिव है, यहाँ नेगेटिव है, सो पोटेंशियल का वेरिएशन हमको ऐसा इंडिकेट करना पड़ता है, पोटेंशियल का वेरिएशन. और बेस्ड ऑन दैट द एनर्जी लेवल्स, इफ यू ऑब्जर्व हियर एट दिस एंड नेगेटिव पोटेंशियल इज अप्लाइड. नेगेटिव पोटेंशियल अप्लाई करने से एनर्जी लेवल इज गोइंग टू बी राइज्ड एंड पॉजिटिव पोटेंशियल अप्लाई करने से एनर्जी लेवल इज गोइंग टू बी लोवर्ड. सो बेस्ड ऑन दैट दिस बेंडिंग इज वी गॉट लाइक दिस. ओके, सो दिस पर्टिकुलर पॉइंट, अभी मैं जो पॉइंट बोला दैट पॉइंट इज वेरी इंपॉर्टेंट. वो क्या है कि पोटेंशियल जब आप अप्लाई करते हैं, पॉजिटिव पोटेंशियल से एनर्जी लेवल राइज, पॉजिटिव पोटेंशियल अप्लाई करने से एनर्जी लेवल लोअर होगा, नेगेटिव पोटेंशियल अप्लाई करने से एनर्जी लेवल राइज होगा. वो पॉइंट तो थोड़ा सा क्लैरिटी देके वहाँ आता हूँ. वो क्या है कि फॉर एग्जाम्पल आप, दिस इज द न्यूक्लियस, this is the nucleus and this is the atom potential level if you observe, and there is an energy level we are taking. Okay, this is the energy level. If applied potential V is 0, the energy level is here in the case of an atom. But when we are considering that is only, for example, here in this particular case, if we are applying the positive potential, this level is going to be now is going to come down. Previously here, but it is now moved down because of the positive potential. The electrostatic potential energy of electron is going to be lowered by the positive potential which is applied to the negative charged electron. So based on that we are going to get like that the situation. And in the same manner, if you observe here, this is nothing but the potential here. If you apply here the negative potential, so previously here it is there, no, previously it is there, but from that it is going to be moved like that, it is going to be raised. So remember, when there is no potential, energy level is here for a particular electron's energy level. But when you apply the positive electrostatic potential, electron being negative, the positive electrostatic potential will lowers the energy level of electron. And when you apply the negative potential, then the electron is being negative, the negative electrostatic applied potential is going to cause electron to rise its energy level. With energy level indication, the rising should indicate. So इसमें मैं ये बोल रहा हूँ बच्चों, स्टूडेंट्स, ये हैं कि अगर आप पोटेंशियल कुछ भी अप्लाई नहीं किया, एनर्जी लेवल यहाँ रहा, लेकिन जब आप पोटेंशियल पॉजिटिव इलेक्ट्रोस्टैटिक पोटेंशियल अप्लाई किया तो एनर्जी लेवल लोअर हुआ, लेकिन जब नेगेटिव इलेक्ट्रोस्टैटिक पोटेंशियल अप्लाई किया, इलेक्ट्रॉन का एनर्जी लेवल राइज होगा, क्योंकि इलेक्ट्रॉन तो नेगेटिव चार्ज्ड पार्टिकल हैं, उसको नेगेटिव इलेक्ट्रोस्टैटिक पोटेंशियल अप्लाई करने से उनका एनर्जी और भी ज़्यादा राइज होगा, इसलिए हमको ऐसा ऊपर इंडिकेट करना पड़ेगा. जब हम पॉजिटिव इलेक्ट्रोस्टैटिक पोटेंशियल अप्लाई किया तो इलेक्ट्रॉन का एनर्जी इज गोइंग टू बी, इलेक्ट्रॉन नेगेटिव वाला चार्ज है ना, इसलिए पॉजिटिव इलेक्ट्रोस्टैटिक पोटेंशियल इलेक्ट्रॉन को अपना लेवल से it will make to come lower. The energy level indication has to be indicated like that, lower. Now coming to that point based, here the conceptual discussion based, here the point, वो क्या है, हमको यहाँ तो नेगेटिव पोटेंशियल आया, यहाँ तो पॉजिटिव पोटेंशियल. सो इस पर्टिकुलर पॉइंट ऑफ व्यू में अब आप देखा तो ये पर्टिकुलर केस में क्या होगा बोलिए, हमको इसलिए हमको ऐसा ये एनर्जी लेवल भी यहाँ देखा तो यहाँ नेगेटिव पोटेंशियल के कारण ये राइज हुआ है और यहाँ पॉजिटिव पोटेंशियल के कारण ये लोअर हुआ है. This one you understood, no? Let me just make it little bit moving like that. Yeah, this picture let me write here. Okay, यहाँ मोर नेगेटिव से नेगेटिव है, यहाँ लेस नेगेटिव से ये पॉजिटिव है. दैट मीन्स हम इस एंड में पॉजिटिव पोटेंशियल, इसमें एंड में नेगेटिव पोटेंशियल एस्टैब्लिश हुआ है ऑलरेडी बिकॉज ऑफ दिस इज नॉन यूनिफॉर्म डोपिंग. ये नॉन यूनिफॉर्म डोपिंग के कारण हमको इस एंड में नेगेटिव पोटेंशियल, इस एंड में पॉजिटिव पोटेंशियल आया था. इसलिए यहाँ का एनर्जी लेवल EV राइज हुआ था. यहाँ का पॉजिटिव पोटेंशियल के कारण यहाँ ये लोअर में ही रहा. ऐसा हमको ये पिक्चर मिला था. इसको लेकर हम यहाँ सॉल्व किया था. ये पॉइंट समझ में आया ना. सो यहाँ इलेक्ट्रिक फील्ड हम बाहर से अप्लाई नहीं किया, वो बिल्ट विद इन द सेमीकंडक्टर बिकॉज ऑफ नॉन यूनिफॉर्म डोपिंग विच इज नोन एज इंटरनल इलेक्ट्रिक फील्ड और बिल्ट इन इलेक्ट्रिक फील्ड विच इज बिकॉज ऑफ द नॉन यूनिफॉर्म डोपिंग. हियर मोर नेगेटिव आयंस इज नेगेटिव, लेस नेगेटिव आयंस इज पॉजिटिव. सो बेस्ड ऑन that end A is positive potential, this end B is negative potential. Because of that only this rising in the energy level was taken place, because I said negative potential से energy level rise होगा. That's why the energy level rised there and here it was lowered. So in this particular way we are going to get the bending of energy levels because of the built-in electric field, even though we are not applying the external electric field. So based on that concept and this mathematical relation, we understood that EV when it is raised like this here, that EV for that relation energy value delta and this L variation of distance is L, and by putting that we got the option delta by QL. Got it? Yeah, this is very interesting, more depth in the concept, but this one is so many times repeatedly in our video lectures I discussed with the students, and exact questions also I gave in the form of PDF with solutions. Already I solved also in the live classes. You can check it, otherwise if you are having the doubt in those videos also. Okay, anyway, thanks for sharing this concept. Actually listening this concept related to this particular problem, and okay, all the best to you. Okay, right, thank you.
Hello dear students, I hope you all have done well in today's GATE paper, and here I am with the solutions for questions from analog circuits which have appeared in today's GATE paper, and all these are questions which we have collected from our students. So if there is some error in the data, then answer may differ. So let me start with the first question. And when I went through these questions, I found them to be on the easier side. I think questions from analog circuits were on the easier side. I could collect 3 questions on op-amp, and there is one question based on MOSFET, and one question is based on a diode clamper. And I find all these 5 questions which I collected to be on the easier side. If you know op-amps, MOSFETs and diode very well, you can easily answer this type of questions. Let's begin with this question, which is based on a negative feedback op-amp circuit. It is told here that in the circuit shown, op-amp is ideal and that input voltage magnitude much smaller than the supply voltage, and reference voltage magnitude is also much smaller than the supply voltage. And we have to find the condition under which output voltage becomes 0. It's a pretty simple question. You can easily solve it by using virtual short circuit property and through KCL. Let me first apply here the virtual short circuit property. So V minus will be at 0 volt. Let me write here. Due to virtual short circuit, V minus equal to V plus, and that is equal to 0. And then we will apply KCL at this inverting node. Let me assume all these currents, okay, as flowing into this node in this way, and just apply KCL at this node. Sum of these 3 currents must be equal to 0. So when I apply KCL here, I get equation V in minus 0 divided by R plus, this we should take as a negative voltage because minus sign is up and plus sign is down. So this current will be minus V reference minus 0 divided by R, and then current in that RF, it will be V out minus 0 divided by Rf. Sum of these three currents will be equal to 0. So let me write here that KCL expression, KCL at V minus node, I mean inverting node, we get V in minus 0 divided by R plus that current in the V reference branch, it will be minus V reference minus 0 divided by R plus V out minus 0 divided by Rf is equal to 0. It is that simple, just a KCL at inverting node. And then I rearrange it, it will become V out divided by Rf is equal to, these terms you can take on the other side, it will become 1 by R into V reference minus V in. Okay, or you can say V out equal to Rf divided by R. Let me just write here, V out equal to Rf divided by R into V reference minus V in. Okay, this is the expression for V out here. And you can treat this circuit as a inverting summing type amplifier also. If that hint comes in the mind, you can tell output expression directly also. This is nothing but a inverting summing amplifier with one input being V in and another input is minus V reference. And you know well, for a inverting summing amplifier, output will be minus Rf by R into V1 plus V2. You can substitute V1 as V in and V2 as minus V reference. In that way also you can solve this particular question. Here I have done it with the help of KCL. And now we want this output voltage to become 0. If you set this output to be 0, let me write here, we desire or we want V out equal to 0. Now this V out will become 0 when V reference minus V in is equal to 0. Okay, if you just equate this V out expression to 0, then we get V reference minus V in is equal to 0, or we obtain a condition V in equal to V reference. So under this condition, the given op-amp circuit will give you 0 output voltage. Okay, V in should be equal to V reference, then automatically V out will become 0. And now just observe, there is no difficulty in this question. Okay, just apply virtual short circuit property and then use KCL at the inverting node and equate V out to 0 and you get the desired condition, V in equal to V reference. Then I will move to the next question. Now this question is based on MOSFET. It's a simple MOSFET circuit. Okay, and the data given is like this. In circuit shown, MOSFET has mu COX 100 microampere per square volt. W by L ratio is 10. If VGS equal to 1 volt, then find threshold voltage VT such that MOSFET is in saturation. Now wording of the question may slightly differ from how it was asked in the actual GATE paper, but this was the data available in the question. We are asked to find out threshold voltage of the MOSFET and the hint available is MOSFET is in saturation region. Now let me first of all write here this transconductance parameter mu n COX into W by L. I'm just multiplying. Mu n COX is 100 micro and W by L is 10. If you multiply this 100 into 10, it will become 1000 microampere per square volt. 1000 microampere per square volt, or I can write it as 1 milliampere per square volt. Okay, this is the parameter mu COX into W by L. And then I will be writing here the drain current. The hint available is MOSFET is in saturation, so I can apply saturation region equation for the drain current. Drain current equal to mu n cox divided by 2 into W by L into VGS minus VT whole square. And here you substitute the data which is available. Drain current equal to, this parameter is 1 milli, so it will become 1 divided by 2 into VGS is given 1 volt, 1 minus VT whole square. This you can call as some equation number 1. That threshold voltage is unknown and we are trying to find that VT. So keep this as it is. And then let us look at the circuit here. This I can show as drain to source voltage VDS, and this will be the drain current. Now from here I can say VDS equal to 3 volt minus the drop across 20k. I have taken current in milliampere, so I can directly put resistor in kilo ohm. Milli into kilo, it will cancel out. So from this diagram, VDS will be how much? 3 minus 20 into IDS. Let me write it here. Drain to source voltage, it is 3 minus 20 into IDS. Now in this equation, you can substitute drain current. We know drain current from equation number 1, that we can substitute here. It will become 20 by 2 into 1 minus VT whole square, or I will get VDS equal to 3 minus that 20 by 2, it will become 10 into 1 minus VT whole square. This is the value for drain to source voltage. And now I will apply this condition. MOSFET operates in saturation. Everybody knows this condition. For MOSFET to be in saturation, MOSFET operates in saturation if VDS is greater than or equal to VGS minus VT. This is the condition. VDS should be greater than or equal to VGS minus VT. Then I will go with that equal to thing. I mean, I will use this boundary condition VDS equal to VGS minus VT in my further solution. And here I will put VDS as 3 minus 10 into 1 minus VT whole square, and that is equal to VGS minus VT. That VGS is 1 volt minus VT. Okay, I'm using here the boundary condition VDS equal to VGS minus VT. That VDS is this much, and VGS minus VT, it will be 1 minus VT. And now you can bring this into quadratic form. What you do is this 1 minus VT, you assume it as x. Okay, so 1 minus VT square will become x square. I'm just assuming 1 minus VT as x to make my solution simpler. This will give you 3 minus 10 into x square is equal to 1 minus x. Sorry, this equal to simply x. 1 minus VT is taken as x. Let me write here x equal to 1 minus VT. And this we can bring into quadratic form. It will become 10x square, okay, plus x minus 3 is equal to 0. And this quadratic you can solve. You can apply standard formula root of a quadratic minus b plus minus under root b square minus 4ac whole divided by 2 into a. So if I apply that root of a quadratic formula, it will be x equal to minus 1 plus minus under root b square, it will be 1, and then minus 4 into a into c, that will be like plus 120 divided by 2 into a, that will become 20. Now this you should solve. It will become x equal to minus 1 plus minus under root 121, it will be like 11 divided by 20. And if you find these roots, you will be getting x equal to 0.5 and minus 0.6, 0.5 and minus 0.6. Every quadratic has 2 roots, so I have got 2 roots here. Now from these x values I will find VT. Let me write, if x equal to 0.5, it means 1 minus Vt equal to 0.5, or I will be getting Vt equal to 0.5 volt. Then you consider the other root also, x equal to minus 0.6. You can say 1 minus Vt equal to minus 0.6, and that will give you Vt equal to 1.6 volt. 1.6 volt. Now to decide which Vt is correct, you need to apply this condition that Vgs should be greater than Vt. Okay, let me write here. Vgs should be greater than Vt, or you can say Vt should be less than Vgs. Now the Vgs value is given in the question, Vgs equal to 1 volt. So Vt should be less than 1 volt. Vt should be less than 1 volt. Therefore, the correct value for Vt, it will be 0.5 volt. And again observe, it is not a difficult question. It is all about using the basic equation of drain current when MOSFET is in saturation. Let us have a quick overview of the question once again. I have first obtained here expression for drain current in this way. Okay, then I have written the value for VDS, 3 volt minus drop across 20k, this will give you VDS. And then I have applied this condition, MOSFET operates in saturation if VDS greater than or equal to VGS minus VT. And here you substitute VDS as this much and VGS equal to 1 volt. And then simplify this further and you will ultimately get VT equal to 0.5 and 1.6. And to decide which VT is correct, we have to apply this property, VGS should be greater than VT or VT should be less than VGS. That is, VT should be less than 1 volt. So in that way, the correct value for threshold voltage is 0.5 volt. So this was question based on MOSFET. Then let me take the other question which is available to me. Now this question is again based on an op-amp circuit having negative feedback. Okay, and it is told in the question that op-amp is ideal and V reference is fixed. This is a fixed voltage. V reference is a some constant voltage. And then it is told that output voltage is 1 volt for input equal to 0.1 volt and output voltage equal to 6 volt for V in equal to 1 volt. And we have to find the ratio RF divided by Rin. We need to find out this resistor ratio, RF divided by Rin. Now this is again a simple question. It can be solved just by using the virtual short circuit property, and then I will be using superposition formula at this node and voltage divider at this node. Okay, let me indicate here, this is a virtual short circuit. Okay, so V minus equal to V plus, V minus equal to V plus. I will calculate V minus by using the superposition shortcut, that V minus will be V out into R in plus V in into RF divided by R in plus RF. And V plus I will find with the help of voltage divider, V reference into R2 by R1 plus R2. Okay, so let me write those values here. V minus will be V out into R in plus V in into RF divided by R in plus RF, and that is equal to V plus, and that V plus we will write using voltage divider, V reference into R2 divided by R1 plus R2. Now the trick in this question is that V reference is a constant value. V reference is a constant value. That means this voltage will be constant. Okay, V plus will remain constant here. That idea should come in the mind. Okay, V reference is a fixed value. Therefore, V plus will remain constant. V in you may vary. Accordingly, V out will vary. but overall this value will be equal to this much, and this is a constant. Okay, so what I do here is I will substitute the available data. When V in is 0.1 volt, V out is given as 1 volt. If you read the question, when V in is 0.1, V out is 1 volt. Okay, let me substitute that. Hope everybody able to follow these things. Put here V out as 1 volt, 1 into R in, okay, plus 0.1 into RF divided by R in plus RF, and that will be equal to this constant value. You can write it as it is, V reference into R2 divided by R1 plus R2. This you call as equation 1. Okay, and then use the other set of data. The other set of data is when V in is 1 volt, V out is becoming 6 volt. That also I will substitute here. 6 into R in plus 1 into RF divided by R in plus RF, and that will be equal to again this constant value V reference into R2 divided by R1 plus R2. Okay, this is your equation number 2. And now you can simply equate equation 1 and 2. In equation 1 and 2, that RHS is same, therefore that LHS must also be equal. Okay, so you can simply equate equation 1 and 2. Equation 1 is equal to equation 2. Hope you are able to understand. In equation 1 and 2, RHS is same, RHS is constant, therefore LHS must also remain constant or must also be equal. LHS should also be equal. So just equate these two values, that R in plus RF, that term will cancel out, and I get simply 1 into R in plus 0.1 into RF is equal to 6 into R in plus 1 into RF, and just look how simple it is. Okay, and then rearrange it further, it will become minus 5 into R in is equal to 0.9 into RF, 0.9 into RF. Okay, I have just done rearrangement. This will give you RF divided by R in is equal to minus 5 divided by 0.9. Minus 5 divided by 0.9. If you calculate this ratio, 5 divided by 0.9, it is coming out as 5.55 minus 5.55. And this was a multiple choice question, and options given in this question, they were all positive, and the correct option will be 5.55. Okay, if you write here magnitude of the ratio RF divided by R in, it will be equal to 5.55. In the among the given options, you can select this particular option, 5.55. But there is some error here in this question. We are getting resistor ratio as a negative value. Now resistor ratio can never be negative, so there must be some correction in the circuit here. Most likely that V in polarity should be opposite. Okay, that's what is my doubt here. This is question which we have collected from our students, so there may be some mistake in the circuit diagram. Okay, that V in polarity should be actually opposite, minus should be up, plus should be down. Then you will get RF by R in as plus 5.55. Anyways, the correct answer in this question will be 5.55. And you please observe here, is there any difficulty here? Okay, I always told in my regular classes that op-amp is the easiest topic, especially negative feedback applications of op-amp. They are the easiest. You just need to apply virtual short circuit property, and then maybe KCL, superposition shortcut, and voltage divider. Here I have used superposition shortcut and voltage divider, and in that way I have obtained answer without any difficulty at all. Okay, So finally, the answer in this question is 5.55. Let me now move to the next question. Now this question is again based on op-amp circuit having negative feedback, and it is told here that this op-amp is ideal and input voltage is as shown, that input is like a pulse signal or a gate signal having amplitude 5 volt and a duration equal to 20 milliseconds, and we have to tell how much is output voltage at t equal to 0 plus. Now what you do first here is, there are two capacitors in parallel, and you know very well from networks, if two capacitors are in parallel, then overall capacitance will be C1 plus C2. So this entire parallel combination we can replace with a single capacitor. Let me draw it here. It will be a single capacitor equal to 2 microfarad. Is that okay? I think each capacitor was of value 1 microfarad, so it will become overall 2 microfarad, C1 plus C2. And now we have to tell how much is V out at t equal to 0 plus. Now this question we can answer quite easily by using basics of network. As you know well, at t equal to 0 and also at t equal to 0 plus, capacitor will act as a short circuit. Okay, that input at t equal to 0 is like a step. If I consider t equal to 0 moment, that input is like a step. But if you know behavior of capacitor at t equal to 0 or t equal to 0 plus, it will continue to act like a short circuit. So if capacitor is acting like a short circuit, then what will happen? Same V in will appear at the V minus node. Okay, this is a very simple question. Let me just write here. At t equal to 0 plus, capacitor equivalent to short circuit. Therefore, that V in, it will be, sorry, V minus will be same as V in, V minus equal to V in, and that V in is how much? V in is 5 volt. Okay, at t equal to 0 plus, V in will become 5 volt. I'm just using here property of the capacitor. At t equal to 0 plus, capacitor will continue to act as a short circuit. Therefore, same V in will appear at the inverting node. So V in will be 5 volt and V minus will also be 5 volt. And how much is V plus? V plus is 0 volt. Let me write here. V plus equal to 0. And you can think it in this way. This equivalent circuit at t equal to 0 plus, capacitor is acting as a short circuit. This is 5 volt. Okay, and this is your resistor having some value, it doesn't matter, and this is your V out. Now at that t equal to 0 plus moment, you can say there is no feedback. Same 5 volt will appear at inverting node, and there is no feedback here. Okay, you have a short circuit here, and same input is appearing at inverting node, and there is no effect of V out on the inverting node. If there is no effect of V out at the input node, we will say there is no feedback. Okay, if a circuit has feedback, it means there should be some effect of output voltage at the input node, but here applied input will appear as it is at the inverting node. Okay, so in that way I will say there is no feedback here, or op amp is in open loop condition. In open loop condition, op amp will act as a comparator, voltage comparator. Okay, that V in will get compared with V plus, and as you can notice here, V minus is greater than V plus, so output must be equal to minus V sat. These supply values are also given, I think they are plus 12 and minus 12, 12 volt and minus 12 volt. So this is a bit conceptual question. There is not much calculation here. It is based on concept of networks and some concept of op amp. From networks, I have borrowed this concept that at t equal to 0 plus, capacitor will act as a short circuit, and that is why same input will appear at inverting node. And because same input is appearing at the inverting node, I will say there is no feedback here, and op amp is in open loop condition. In open loop condition, op amp will act as comparator. Its output will be plus Vsat or minus Vsat, and that will depend on that comparison. Right now Vin is greater than V plus. Vin, or let me write it in this way, V minus is greater than V plus, so output must be equal to minus Vsat. If inverting voltage greater than non-inverting voltage, then output will be minus Vsat, so output will be minus 12 volt. Now this question can be answered in less than a minute if you know behavior of capacitor at t equal to 0 plus, and if you know behavior of op amp in open loop condition. Is that okay? Op amp is acting as a comparator and Vin is greater than V plus, therefore output should be equal to minus Vsat. So in that way output will be minus 12 volt. For this question the correct answer will be V out equal to minus 12 volt. Then we will move to another question. Now this question is based on a diode clamper. This type of circuit is called actually clamper. As you can see, the diode is pointing downward. It means it's a negative clamper. Okay, it is a negative clamper. And the data available is diode is ideal and input is a periodic pulse train of amplitude 10 volt with a t on 1 millisecond, t off 1 microsecond. You have to find the difference of maximum V out and minimum V out. You have to find this difference, V out max minus V out min. Now this is also a simple question. If you know operation of a clamper, you can solve this question easily. Let me quickly draw here the waveform for input. Input is like a pulse train like this, in this way. This is the input waveform. This 0 volt and that amplitude given as 10 volt. This is called T on. This is given as 1 millisecond. Okay, and the T off, it is very small. It is only 1 microsecond. And now you recollect operation of a clamper, how clamper will work. When Vin is plus 10, I'm talking about this interval. When Vin is plus 10, that diode will be in forward bias. And with diode in forward bias, diode will act as a short circuit and capacitor will rapidly charge through the diode up to 10 volt. Let me write that. Vin equal to 10 volt. Diode will act as a on device. Diode is on. And that circuit I can redraw like this. Diode will act as a short circuit like this. And this is your input, which is 10 volt. Okay. So what happens here is this resistor doesn't matter because it is in parallel to short circuit. Okay. Capacitor will simply charge through this diode only, and capacitor will charge up to 10 volt. Capacitor will charge up to 10 volt through diode. Okay, and this resistor has no effect because it is in parallel to short circuit. Okay, capacitor will charge through the diode up to 10 volt. Capacitor charges up to 10 volt, or you can say Vc equal to 10 volt. It will be a rapid charging. Capacitor is charging through short circuit, so it will charge rapidly up to 10 volt. And then I consider here Vin equal to 0. Now when Vin becomes 0, that diode will be off. Diode becomes off. And now the circuit can be redrawn like this. Diode will be acting as a open circuit here. Okay, and this capacitor is of value of how much? Capacitor value is 20 nanofarad. 20 nanofarad. And resistor is of value 500k. 500k. And this input has become 0 here. Okay, input has become 0. Now what we expect is capacitor should discharge through the resistor here. Okay, when diode was on, capacitor got charged up to 10 volt like this, and when diode is becoming off, in that interval this capacitor should discharge. But if you notice that discharging time constant, it will be very high. If I write here tau discharge, discharging time constant, this is discharging time constant R into C. Okay, you just multiply 20 nano into 500k. Let me find out this. 20 nano into 500k, it is coming out as 10 milliseconds. 10 milliseconds. And if you notice this discharging time constant, it is much greater here in comparison to T off. Tau discharge is much greater than the T off. In the question, that T off is given as only 1 microsecond. Okay, diode is off only for this much interval. The T off is 1 microsecond, whereas discharging time constant how much? 10 millisecond. 10 millisecond is much greater in comparison to 1 microsecond. That means capacitor discharges negligibly. Capacitor discharges negligibly. There is a negligible amount of discharging. Now this is standard behavior that we observe in a clamper. Okay, charging happens through diode and that will be very fast, and then when diode becomes off, capacitor is supposed to discharge through the resistor, but the discharging time constant is very high. Therefore capacitor will discharge negligibly, and therefore capacitor voltage will remain constant at 10 volt. Vc will remain approximately constant at 10 volt. This is standard behavior of a clamper. I have told many a times in my regular class that in a clamper, once capacitor fully charges, then after that capacitor voltage will remain constant. There will be no charging further and there will be no discharging further. So in this way I will say capacitor has attained steady state. Okay, capacitor voltage will remain permanently constant at 10 volt, or you can say capacitor has reached steady state. So let me write here, in steady state Vc equal to 10 volt. Vc equal to 10 volt. And now you can easily tell the output voltage. Output voltage will be Vin minus Vc. You can assume this as capacitor voltage, which is 10 volt. So V out will be how much? Vin minus Vc. And that is how we write output of a clamper. V out is equal to Vin minus Vc. It will be Vin minus 10 volt. You can say a DC voltage minus 10 volt is getting added to the input. Okay, a constant voltage or a DC voltage minus 10 volt is getting added to the input, and that's how we call it a negative clamper. It will add negative DC to the input. And now you can easily find maximum and minimum V out. When V in is 10 volt, then corresponding V out, it will be 10 minus 10 equal to 0 volt. And when V in becomes 0 volt, then the corresponding V out, it will be this input is 0 minus 10, it will be like minus 10 volt. So I can say in this circuit maximum V out is 0 volt and minimum V out is minus 10 volt. So let me write here V out max minus V out min. It will be equal to 0 minus of minus 10, or it will become 10 volt. That V out max minus V out min, it is basically the peak to peak value. Okay, V out max minus V out min, it is nothing but peak to peak value of the output. If you draw output waveform in steady state, that output in the steady state, it will look like this. I am drawing here steady state V out, steady state V out, output in steady state, and that output will be nothing but a pulse train only, but it will be looking like this. This is the waveform for the output. This will be 0 and this is minus 10 volt. And you can notice, because it is a negative clamper, it has shifted the waveform downward. And this question can be solved without doing any calculation also. You can apply property of a clamper. Okay, when a signal is applied to clamper, the signal shape does not change and peak to peak value also does not change. Clamper changes only DC level of the signal. Clamper changes only DC level of the signal, but clamper does not change signal shape and clamper does not change peak to peak value of the signal. Input has a peak to peak value, how much? 10 volt. Input has a peak to peak value 10 volt. So output should also have a peak to peak value 10 volt. That V out max minus V out min, it is nothing but peak to peak value of the output also. So this question could have been attempted in less than 30 seconds also by using this property, that clamper does not change peak to peak value of the signal. Input has a peak to peak value 10, output should also have a peak to peak value equal to 10. So that's how answer for this question will be 10 volt. Hope everybody understood this part. I will have a quick recap here. Okay, I haven't done anything extraordinary here. Okay, it's all basics. When input 10 volt, diode will be on and capacitor will charge through the diode rapidly. Charging will happen very rapidly. Charging time constant is 0 here. Diode acting like a short circuit. Okay, charging time constant is 0. So capacitor will charge rapidly up to 10 volt. And when input becomes 0, the diode will be off and equivalent circuit will look like this. And now capacitor is supposed to discharge. Okay, when diode is off, capacitor is supposed to discharge through this resistor, but what we observe is discharging time constant is 10 millisecond, and that is much greater than T off. That T off is only 1 microsecond. 10 millisecond much greater than 1 micro. That means capacitor will have negligible amount of discharging, and therefore capacitor voltage will remain approximately constant at 10 volt. And that's how we say that capacitor will now be in steady state, because capacitor voltage will always remain at 10 volt only. If capacitor voltage is remaining constant at 10 volt, I will say capacitor has attained steady state. In that steady state, Vc will be 10 volt, and then V out will be V in minus Vc or V in minus 10, and then you calculate V out by putting input as 10 volt, input as 0 volt. You will get corresponding V out 0 volt minus 10 volt, and then V out max minus V out min, that will be how much? 0 minus of minus 10, 10 volt. Or you can tell it orally also, peak to peak output should be same as peak to peak input in case of a clamper. Peak to peak input is 10, so peak to peak output should also be 10 volt. So these were some questions which we have collected, okay, from our students only, and based on that collection of questions we have prepared solutions here. And if there is some change in the data or error in the data, then answer may differ, and maybe when IIT Bombay releases the actual gate paper, then we will try to prepare these solutions once again. Thank you so much.